Hi guys, and welcome to your first video in this Python refresher. In this video, let's talk about variables. A variable in Python is a name for a value. You can think of them as similar to those in algebra, but there are slight minor differences that you'll understand as you program more in Python. Here's how we define a variable. You can define the variable name, for example, x, and then you'll type a equal sign, and finally you'll type the value, for example, 15. And what Python is doing here, and this is very important, is it's creating this value that's after the equal sign first. So here Python sees the value 15 and it says, okay, you're going to use the value 15. I will, create that or store that somewhere. And then it's going to say, and what am I going to refer to that value as? And that's going to be x. So the right side of this assignment, this equal sign, happens first, and the left side happens later. And so at this point, there are a few values in Python where Python has already created them before it runs your code. So Python doesn't create these values when you use them, but if you have something like 1500, then Python will do what I just said. It will create this value and store it in its memory, and then x will become a name for this value you just created. As well as integers, which are whole numbers like we've got here, you can define variables such as 9.99, and here what I've done is I've created the value 9.99, which is a float value or a value with a floating point, and then I've told Python to give that value the name of price. Let's say we've got a variable called discount and it equals 0.2. We can then say that the final result of our price when the discount is applied would be the price multiplied by 1 minus the discount. And here's what happens when you execute this. Of course, following the rules of mathematics, which Python does, this gets evaluated first since it's between brackets, and you get 0.8, 1 minus 0.2. Then you're going to multiply 9.99 by 0.8, and that value will get calculated and stored in Python's memory. Whatever that is, result will be the name for that value that we'll refer to from here on. If you wanted to print a value out and show it to the user, you can very easily do that with the print function. So here we will type print, and then inside brackets, we will type result. The brackets in here are not the same as they are up here. Here they were used for order of preference in mathematical expressions, and here they are used to signal to the print function what we want to print. And this is fairly common in Python. Whenever you see a name, such as print, followed by these brackets, what you've got is a function. And a function in Python is something that performs an action, such as showing something to the user, or it calculates an output based on some inputs, or it can do both. We're going to look more at functions in a coming video. But this is how you'd show the user something in the console. So at this point, I'm going to save this file and I'm going to run it. And you can see that the output is 7.992. So this output here is what this line 8, this print function, will calculate. Notice that we've got a number of other variables up here, but we are not printing them out, so they will never be shown. As well as integers and floats, Python has another data type called the string. Integers and floats are used for mathematics or for calculating things, whereas strings are used to store characters. For example, a person's name, a person's date of birth, a person's phone number, so on. Even though some of them do contain numbers, they're not going to be used for mathematics, those values, so we can store them in a string instead. Let's say that we want the person's name to be stored. What we'll do is we will say name equal, and then inside quotation marks, we will type Rolf. What Python does is it creates this string first, and then this name here becomes a name for that string. Notice that you can reassign a name, so that we can do something like this if you'd like. And now, name, instead of being a name for Rolf, will be a name for Bob. So no two variables are created here, it's just the same variable, but we have essentially moved it. You can of course print this out if you want. And I will save this file and run it. And you'll see down here that we get Rolf printed out because that is the contents of our string. Note that Python uses the quotation marks to signal a string, but these quotation marks themselves are not part of the contents. They are just used as delimiters. Instead of double quotation marks, you can use single quotation marks if you like, and that is totally fine as long as you don't mix and match them. If you mix and match them, then that won't work and Python will complain. I recommend you always stick to one same type of quotation marks, and I generally use double quotation marks. What happens if we print the name multiplied by 2, which is how you would multiply any number? When you run this, you'll see that the output is now Rolf, because that's line 3, and then you get Rolf for line 4. What's happened here is this has essentially done name plus name. It added two names together. That's the same meaning as the multiplication. And when you add two strings together, what Python does is it will join them, and it will add one after another, so you can end up with a longer string. This can be very useful at times, but normally is not what you want when you multiply a string by a number. Let's say you have two variables, a equals 25 and b equals a. I mentioned earlier that 25 is a special value because it is under 255, so Python creates it as soon as Python starts up. If it was a larger value, then at this point Python would create it. So we get the value 25, and we say that a is a name for that value. From here on, we can refer to a, and really we'll be referring to the value 25. So what happens when b equals a? Well, Python is going to evaluate a, and it's going to say, okay, a is a name for 25, so we're going to use 25 here instead. So this means the same thing as this. And then b is now a name for a, which really means that b is a name for 25. So now both a and b are names for the number 25. So you can verify that that's correct by printing them both out. So I'm going to print a and then print b, and you'll see that we get 25 and then 25, which is perfect. But what happens if we do b equal 17? Should a be 17 as well? Well, let's run that. And now down here, you get 25 and 25 for lines 4 and 5, and then you get 25 and 17 for lines 9 and 10. What we've done here in line 7, when we said b equals 17, is we've told Python to evaluate the value 17, and then make sure that b is a name for 17. Python completely disregards that b was a name for something else before, and it just says, okay, this b thing is a name for 17, a is completely unchanged. The assignment expression, when used like this, does not change other variables. It just changes the variable that you refer to. There are ways for us to change a by using b, but not when we're talking about integers. We will talk about that later on in the videos when we learn about mutability in the language. Alright, that's it for this Python refresher on variables. Do remember that this is not a Python introduction course, because we've talked about some quite advanced things here, but it's just to get you back up to speed with Python in case you have experience from before or with other programming languages. Thank you for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about string formatting in Python. Specifically, we're going to be using a newer Python feature from Python 3.6 onwards. So for this video, make sure that you're using Python 3.6 or later. Let's say that you've got two strings. One which is Bob and has the name of name, and one which is hello Bob and has the name of greeting. If you print greeting out, of course, you're going to get hello Bob, since that are the contents of the string. But if you set name to Rolf and then you print greeting again, then naturally as you run that, you're going to get hello Bob and then hello Bob again. Greeting contains the string name, which is Bob, but it doesn't calculate it dynamically, which means that when greeting is defined, it contains the characters hello, comma, space, Bob. And then changing name doesn't change that greeting. So if you wanted to change the greeting, you would have to do something a little bit different. Indeed, instead of typing hello, comma, Bob, what you'd like to do is to put an F in front of the quotation marks. So now we've got what's called an F string in Python. An F string allows us to embed variables inside of strings. So here, instead of hello, Bob, we can do hello, name inside these curly braces. Now, again, we've got F, and then inside the string, we can use the curly braces, and inside the curly braces, we can put a variable name. So when this is calculated, name will be replaced by Bob. So we will print out hello, Bob. So if we run that, you'll see down here that we get hello, Bob. So exactly the same thing as before. At this point, I'll say that if you do what we had earlier and set name to Rolf, and then you print greeting again, you'll have the same problem as before. So if you press play again, you'll see hello, Bob, hello, Bob. So what we've done here is we have embedded the variable inside the string with the value that that variable had at this point in time, in line 2. So in line 2, name had the value of Bob, so greeting is hello, Bob. So what is the point of using the F string if it doesn't change dynamically? Well, the good thing about this F string is that instead of defining a variable for it, if you wanted to have a different value each time, you could just print it out like that and get rid of this variable definition. Now, what we've got here is we are printing, and inside the brackets, we've got the value that we want to print. So here we have the F string, which includes an F, then the quotation marks, and then the characters inside it, including the variable. By doing something like this, now every time you run this code, you're going to use the name at its latest point in time. So we get hello, Bob, and hello, Rolf. There is a way of defining a template, which instead of calculating it at the time where it is defined, you can calculate the values to be replaced inside it later on. Here's how you do that. So you can define your greeting as hello, and then open and closing curly braces. Notice that we don't have an F in front of it. Then you can say that with name, which is another variable, is greeting.format and then name. So what we've done here is we have created now 3 strings. We have the string name, which has the value Bob. We have the string greeting, which is our template, which says hello, curly braces. And finally, we say greeting.format, and then inside brackets, we put in the name. So what this is doing is essentially it's calling the format function inside of greeting. And what that's doing is it is giving the name to this template. And what the template will do is it will replace the curly braces by the contents of the name variable. So with name will contain hello, Bob. If we print that out, you'll see what I mean. You get hello, Bob printed out. One of the benefits of this is that you can then use this with name with other things. So you can reuse the template, the greeting, and instead pass in Rolf, for example, and then if you run this, you'll get hello, Rolf. So it allows you to define a template that you can reuse with multiple values. Notice that in here you can have one with Bob there, then you can have one with Rolf, and you can do that everywhere there. So now you have reused the template 2 times to create 2 different strings. This is why the format can be useful instead of F strings, but generally you'll be using F strings if you're using Python 3.6 or later. Another benefit of using format is that you can create longer templates. For example, here we've got a longer phrase that says hello, placeholder. Today is placeholder. So we can say longer phrase dot format, and then we can pass in Rolf and Monday. And what this will do is it will put the values Rolf and Monday into the placeholders one at a time. So Rolf will go into the first placeholder, Monday will go into the second placeholder, and then you can print this out, and you will get back the appropriate value. Hello, Rolf, today is Monday. Again, you could do this with many different strings, so that is something that is available if you'd like to use it. But generally, you'll be using F strings. Those are the 2 main ways of doing string formatting in Python, which means essentially to embed values inside a string. There are other ways which are older, but we're not going to be learning about those in these videos just because they're not really used all that much anymore. Thanks for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, we'll learn about getting user input so that we can get some data from our users and use it in our programs. Let's start off by asking the user for their name so we can print it out. We will say name equals, and again, this is us defining a variable. Now we have to tell the variable what its value is going to be. So what we're going to do here is we're going to ask the user for their name. And the way we do that in Python is we type input, then a pair of brackets, and inside the brackets, we are going to type a question that will ask the user, or a prompt. So here goes a string where we put enter your name. So here we're calling another function, just like the print function, but in this case, this function here will print this prompt out, and then it will wait for the user to type and press enter. Then we're going to print out the name. So I've run this code here, and you can see that we get asked to enter our name. I'm going to type here Rolf, and then Rolf comes back out. So this is how you can ask the user for their name, or indeed any other piece of data, and then use it in your programs. If you wanted to ask the user for a value that you want to do mathematics on, then there is something important to take into account when you're coding in Python, and that is that the input function always gives you back a string. So this input will ask the user for a value, and it will give you a string. Now, remember that you can't do mathematics on strings in the same way that you can with numbers. So if you wanted to calculate the amount of square meters that is the equivalent to the size of their house in square feet, you would do size input divided by 10.8, that's more or less the right number, and then you can print square meters. But remember that you can't do maths that well. So if I save this and then I go ahead and run it, and I ask, for example, my size is 500 square feet, you're going to get an error. And you can see here that you've got a type error, and it says unsupported operand types for the division, string, and float. So what this is saying basically is that we've tried dividing a string by a float, and you can't do that. So we need to convert this into a number instead of a string. So what we've got to do is we have to first turn this size input into a number. So what I'm going to do is I'm going to define a variable called square feet, and I'm going to say int of size input. And what this is doing is it's doing something like what we had before. We are passing size input into another function, which is this int. And that is going to try to turn our string into an integer, a whole number, so that we can then do maths on it. Notice that here in our square meters line, we're still using size input, which is our string. If we want to make sure that we use the number, we must use this square feet variable that we've defined on line 2. Otherwise, that means we're still using the string. Let's save this and then run it. So here we've got this app running, and I'm going to type in 500, and now we get 46.3. So here's a small challenge for you. Try to print something a little bit nicer rather than just the square meters. For example, you could print something like this number of square feet is equal to this number of square meters. I'd recommend pausing the video and giving it a go, but I'll try and do it right now as well. We're going to use an F string, so I will type the F key and then the double quotation marks, and inside it I'm going to use my square feet variable and type square feet is square meters. Notice that this here is the variable that we want to put the value of inside our string. So we still have to say what that variable means. So for example, 500 square feet is 46 square meters. So if we run this again, you'll see that as soon as I type 500, we get a nicer input. 500 square feet is 46 square meters. If you want to format a floating point number so that you only get a certain number of digits at the end, you can do .2f, for example. So here what we've got is a slightly more obscure piece of syntax. We've got square meters, colon, .2f. And what that does is it will try to format this square meters with 2 decimal places only. This is what this piece of syntax means. So I'm going to save that, run it again. And now you see we get 46.30 square meters. If you want to learn more about this formatting syntax, I'm going to leave a link in the resources section of this lecture or on the description below so that you can have a read at that. But that's everything for this video. We've learned how to get user input and how to turn it into a number in case we need to do maths on it. Thanks for joining me in this one, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about lists, tuples, and sets. 3 different collections in Python that allow us to store multiple values in a single variable, so that we can use them all at once or maybe extract some of them individually. Let's get started. We're going to define one of each, just so you know how they are defined. So L is going to be a list of 3 elements. And here I've created a variable called L for list, and I've made it equal to a list. The list is defined by using square brackets, and inside the square brackets you can put different values as long as they are separated by a comma. So what I've got here is one string, then I've got a comma, then I've got another string, then I've got another comma, and then I've got another string. So 3 strings separated by commas inside square brackets. This defines a list. If you didn't have lists or tuples or sets, you would have to define 3 variables, 1 for each friend. And that would make it difficult to interact with all the values at once. You'll understand what I mean as we progress through the video. A tuple is very similar to a list, but instead of using square brackets, you use normal brackets. The key difference between lists and tuples is that you can't modify a tuple. Whereas you can add and remove elements from a list, you can't add and remove elements from a tuple. That's the key difference between the 2. Finally, a set is again very similar, but you use curly braces instead of square or normal brackets. And the key difference between a set and the other 2 is that while you can add and remove elements from a set, you can't have duplicate elements, so you couldn't have Bob twice in the set. Also, lists and tuples keep the order of the elements. So whenever you print out this list, it's always going to have Bob, then Rolf, and then Anne in that order. But sets don't necessarily keep the order, or rather the order is not guaranteed, so the order could change at any moment. Sets are useful in a few scenarios that we will learn about in the coming videos. You can access individual elements of a list or a tuple by using subscript notation. So for example, you can print L and then 0 in square brackets. So what we've got here is our list variable, and then we've got square brackets, 0, and close square brackets. This notation here is called subscript notation, and you can apply it to many things in Python, but you can use it on lists and tuples, and what it does is it gives you that element, the element with index 0. Elements in programming usually start counting at 0, so the first element here, Bob, has an index of 0. Then this one has an index of 1, and this one has an index of 2. So you could access Anne by doing L2. This also works for tuples, so you can use your tuple variable there instead, and that's totally fine as well. However, it doesn't make sense to do that in sets because they don't have any order. So if you access the third element of a set, you don't know what you're going to get. That's why sets don't allow you to use subscript notation on them. You can modify individual items in a list by accessing the item itself using subscript notation, and then treating it like a variable. So for example, you can say L0 equals Smith, and then if you print your list and you run it, you'll see that the first element is now Smith, second one's Rolf, and the third one's Anne. However, if you try to modify a tuples element and you run this file, you will actually get an error because tuples cannot be modified after they're created, so you can't use the equal sign on anything inside a tuple. Of course, you cannot do this on a set because a set does not allow for this subscript notation. You can add elements to a list by doing l.append, and what append does is it will add an element to the end of the list. So if we append, for example, Smith to this list, and then we print it out, you'll see that this list will now have 4 elements. That's Bob, Rolf, Ann, and Smith. But again, because tuples do not allow modification, you can't change them, then if you do something like this, you're also going to get an error, and it's going to tell you that the tuple object has no attribute append. What that means is that we've tried to access something called append inside, that's what the full stop means. So we've tried to access append inside of our tuple, but our tuple doesn't have anything called append inside it. We're going to learn more about what I mean by inside in the next few videos. It is a little bit of a more complicated topic, but rest assured that you can't add things or remove things from a tuple. Talking about removal, you can remove things from a list by doing l.remove and then passing in the element that you want to remove. For example, if you wanted to remove Bob, then this would do that. And then if you print L, then you'll see that Bob has been removed and you are only left with Rolf and Ann. Going back to adding, you can add things to a set. So you can do set add Smith, and then you can print your set. And here you can see that you get Ann, Bob, Smith, and Rolf. Notice that the order is not the same as when we created this, but all the elements are there. However, if you do the same thing twice, you'll see that Smith will only be here once. That's because even though we told the set to add Smith twice, there can be no duplicate elements inside a set, so the second Smith is actually ignored. This was a very brief primer or refresher regarding what lists, tuples, and sets are. So just remember that lists are the most standard collection where you can add and remove elements as well as modify them. In a tuple, you have those elements and you can't modify them and you can't add or remove elements. And finally, a set has no duplicate elements and it also has no order. That's everything for this video. Thank you for joining me, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about advanced set operations. That is, why sets are useful. So, let's say we've got some friends, Bob, Rolf, and Ann, and then we have 2 friends that are abroad, Bob and Ann. If only Bob and Ann are abroad, that means that Rolf must not be abroad. So the local friends are actually a set with a single element, Rolf. This is how you define a set with a single element, exactly the same as with multiple elements, but you don't have a comma with more elements after it, so you've got just your single friend inside the curly braces. However, if you add more friends, or you add Rolf to the abroad friends, of course this variable will not change. That's because you're saying that this variable contains a set with a string Rolf inside it. It is not related to these 2 sets. So instead of hard coding the set to be a single element, we're going to use these 2 sets to calculate who is local, which friends are not abroad. And the way to do that is by doing friends.difference abroad. So what this does is it calls the difference function inside friends. And this function here takes in another set. And what this will do is it'll take this set and remove from it the elements in this set. So it will essentially calculate the difference between the 2 sets with this one as the starting point. So it will take away Bob and Ann, leaving you just with Rolf. You can indeed print that out, and you'll see what I mean. So there we have our single set, Rolf. Notice that if you do abroad.difference with friends, you're going to get something different, because abroad has 2 elements, Bob and Ann, and what you're going to do is you're going to remove from this set the elements in this set. So you're going to take away Bob and Ann, and Rolf as well, but Rolf is not even there. So you're going to end up with an empty set. Indeed, if we run this, you'll see that you get an empty set at the bottom. And by the way, this is the notation for an empty set. If you want to create one that's empty with no elements at all, you have to use set and then normal brackets. And that is also how Python tells you about an empty set. So again, difference takes one set and removes the elements in this other set from it. If instead of a list of friends and a list of friends who are abroad, we had a list of local friends and a list of abroad friends, we can also calculate the total friends using another set operation. So what we'll say is friends is now local dot union abroad. And what union does is it unites two sets and it gives you the total of both. Here we will add to Rolf, Bob and Anne, and we will end up with a set that contains Rolf, Bob and Anne. So if we print friends, you'll see that that is indeed what we get back. Now let's say we've got a bunch of friends, some of whom study art and some of whom study science. So the friends who study art are Bob, Jen, Rolf and Charlie, and the ones who study science are Bob, Jen, Adam and Anne. So you can see that Bob and Jen actually study both art and science, Rolf and Charlie study art only, and Adam and Anne study science only. You already know how to calculate from these two sets, the ones that study art only, and the ones that study science only, by using the previous operations. But what we don't know is how to find out which ones study both subjects. So that is where intersection comes in. We can say that another variable, both, is art.intersection science. And then if we print both, you'll see that the output will be Bob and Jen. I'd encourage you to have a play around with these set operations because they can be a little tricky to understand fully. But once you've given them a go and you've tried them out, I'm sure it'll all be much clearer. In the resources section of this lecture or in the description below in the video, I'm going to link a couple of blog posts that we've written on these set operations that also add a few more that can be helpful as well, such as symmetric difference. Thanks for joining me in this video, and I'll see you in the next one. Hi guys and welcome back. Just a quick video to tell you about Booleans. A Boolean is a value that can be either true or false. And we can use that to make decisions. For example, using Boolean logic, we can tell whether a user's age is over 18, or whether the user's character in a game has pressed the up arrow. Things like that are what we need Booleans for, and they are everywhere in Python and in programming. Let's learn more about them. Booleans are created by using comparisons. So you can compare two things together to calculate whether two things are the same or different. For example, if you print 5 = 5, this is a Boolean comparison. 5 = 5. Notice that a single equal sign is used to assign a value to a variable, but two equal signs one after another are used to compare two things. And what we're comparing here is 5, and we're going to check whether it is exactly equal to 5. So these two numbers here are being compared, and we're going to get true if they are exactly equal, and we're going to get false if they are in any way different. So if I run this here, you'll see that we get true out. As well as equal, you can use the typical maths operators such as greater than to calculate whether a number is greater than another number. And there you get false. As a special case, you've also got !equal, which is used to tell whether two things are different. So what this reads as is 10 different from 10? So again, you'll get true if they are different, and you'll get false if they are not different. So here we should get false, because they are not different. Other comparisons that are available, as well as equal, not equal, and greater than, are less than, and greater than or equal to, or less than or equal to. And this is how you write them in Python. So you can check whether something is less than one thing, whether it's greater than or equal to something else, or whether it's less than or equal to something else. I'll say at this point that you can use these operations not only on numbers, but on any other value, including lists and tuples and strings and whatnot, but they can behave differently depending on what type of data you use them on. We're going to learn more and get more acquainted with how they behave in different scenarios as we go along, with better examples, of course. So these are the comparisons, and as well as comparisons, you've also got a few Python keywords that you can use to calculate Booleans. One of the more confusing keywords in Python when you're talking about Booleans is the is keyword. So here we've got two lists, friends and abroad, and they have the exact same elements inside them. You can print whether friends equal abroad, and when you run this code, you get back true. Because the equal sign, when you're talking about two different lists, compares whether the elements inside them are the same. And here, because you're comparing two strings, then Python can detect that these two lists are actually the same. However, a lot of new Python developers will try to do friends is abroad, which is something you can do in Python, but you won't get what you expect because you get false. That is because when you create a new list, Python goes and creates some space in its memory for this new list. The elements can be stored somewhere else, but the list itself has its own area in memory. Then when you create another list, it goes and creates another area in memory for this other list. The elements inside the list were created separately, and they could be the same between both lists, but the lists themselves are different. And that is what the is keyword checks in Python. It checks whether two elements are exactly the same thing, not whether they have the same elements inside them or whether they are similar. So again, the is keyword is to compare whether two elements are the same thing. So if you do friends is friends, for example, you're going to get true. If you say abroad equal friends up here, and then you check whether friends is abroad, you're also going to get true because you haven't created two lists. You've just pointed the two variables to the same list. And that, again, is what the is keyword is for. I recommend you almost never use it. You're almost always going to want to use the double equal sign. Alright, that's it for comparisons and this brief introduction to Booleans. Let's learn more in the next video. I'll see you there. Hi guys, and welcome back. In this video, we're going to learn about if statements. An if statement allows us to use a Boolean to make a decision in our program and potentially do different things depending on the value of that Boolean. Of course, if statements are most useful when you have user input, such that your program can potentially get different data depending on who runs it and who's using your program. So here we've got an input that asks the user for the day of the week. So what day of the week is it today? And then we're going to check whether the current day of the week is Monday. So how would you check whether the current day of the week is Monday? You would say day of week equal the string Monday. Let's print this out to see whether our Boolean works. So all I've done is printed the Boolean out. And again, remember that this here will evaluate first. So Python will say day of week is equal to Monday. And if it is, then it will replace this entire thing by true. Otherwise, it will be replaced by false. And if we run this, you see that we get our prompt, and you can type in Monday, and then you get true. But if you type Tuesday, then you get false. So this is what we expected. Now, instead of printing this out, we can actually put it in an if statement. So the if statement is like this. You type in your if keyword, which is special in Python, then you put a space, and then without putting brackets or anything, you type your Boolean comparison. And then at the end, you put your colon. This will evaluate as soon as the if statement runs. So as soon as Python reaches line 3, it's going to calculate the result of this Boolean, which is going to be true if the user entered Monday and false if they didn't. And if it is true, then we will run the code underneath the if statement. And here's one of the most important things in Python programming, which is that there are a few spaces in front of this line here. This is called indentation in Python. And after a colon that defines a block of code, such as an if statement or a function or a class, we're going to learn more about those later on, you need to put indentation. That is how Python tells which code is inside the if statement, i.e. which code you want to run when this is true. So, for example, you can print have a great start to your week. Now, this is the line of code that is inside the if statement. If this is true, this line of code will run because it's got these 4 spaces in front. I'll say at this point that you don't have to use 4 spaces in Python. You can use 2, you can use 6 or 8, whatever you want, but be consistent. So always use the same number of spaces. That's going to make your code work. Otherwise, it may not work, and also it's going to make your code look much better. If you've got different indentations in different parts of your program, people are going to be really confused when they look at your code. I recommend using 4 spaces for Python code. Now, if you print something and you remove the indentation, the spaces in front, for example, like this, what you're going to get is that this code is always going to run if this is true or if it is false, because it's not in the if statement, it's completely unrelated to the if statement. So Python will run this code. If it's true, it will run this code. If it's false, it will not run this code, and then it will jump to the next line, and then it will continue running from here. So I'm going to run this down here again, and I'm going to type Monday, and then you see that we get have a great start to your week, and this always runs. But if we type in Tuesday, then you just see this always runs, and you don't see the great start to your week. If you want to print something if the day of the week is not Monday, then you can do something like this. If day of week is not Monday, then print full speed ahead. Let's run that, and then I'll type Monday, and you get have a great start to your week. But if we type Tuesday, then you see full speed ahead. Now, this is actually not great Python code because you have 2 checks that will always be evaluated by Python. Here you've got day of week equal Monday, and this will always be checked whether it is true or false by Python. And then you have day of week is not equal to Monday, and this will always be checked by Python, regardless of whether this one was true. Evidently, if this one is true, this one cannot be, and vice versa. So Python provides you a very nice piece of syntax called the else syntax. And what this does is, if this is true, then we run this code. Otherwise, run this code. So this is much nicer, and also it's much easier to read. Let me say at this stage that only one of these 2 will run. You cannot possibly run both, because you can't have this be true and also false at the same time. In addition, if you wanted to print something else, if the day of the week is Tuesday, you can do elif day of week equal Tuesday. And what this does is it creates a chained if statement, an if statement with 3 different branches. First, Python will check whether the day of the week is Monday, and it will print this if it's true. But if it's not true, then Python will check whether the day of the week is Tuesday, and it will print this if it is true. But if neither of those are true, then it will go to the else. An important part of this syntax here is that if the day of the week is Monday, then Python will print this stuff, and it will ignore the rest, so it will never calculate this comparison. So this is actually good for performance, and also it lets you have a comparison here that when it evaluates and when it's true, it ignores the rest. So there's actually a lot of stuff you can do with this knowledge, and you'll encounter that plenty while you're doing Python programming. A common problem when you are dealing with user input is that they may not enter exactly what you expect. For example, it's quite common for a user to enter all lowercase letters when you ask them for something, just because they can't be bothered typing the uppercase letters. So here the user has typed Monday all in lowercase, and then we have printed out full speed ahead because day of the week is not exactly equal to the string Monday with a capital M. So you have to do something about it if you want your program to be able to detect whether the day of the week is Monday in uppercase and in lowercase. What I'd recommend is that you get the user's input, and just after you type .lower. And then this is going to turn this entire string into its lowercase variant. Now, if they enter Monday with a capital M, then it is also going to be turned into Monday with a lowercase m, which means that Monday equal Monday with an uppercase m will not match. So instead what you should do is turn everything to lowercase. By turning the user's input into lowercase and your checks into lowercase, you're always going to have the same case because they're both lowercase. So if we save that and run it, you'll see that now I can type Monday, but I can also type Monday all in uppercase, and I can also type Monday as usual. So this is a good way of ensuring that your program will work no matter what type of case the users type. Let's leave it at this. Thank you for joining me in this video. I hope it's been useful, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about the in keyword in Python. The in keyword is something we can use to check for membership, whether one thing is inside a list or a tuple or a set. Let's get started. I'll have a list of friends which contains Rolf, Bob, and Jen, and then we can very easily print whether Jen is in friends. And this is going to check whether the string Jen is one of the members in this list. So if we save that and run it, you'll see that we get back true. Now let's say that we have a set of the movies we've recently watched. I'm using a set here because movies are unique, so you can't have duplicates, and having a set actually helps you prevent duplication. In addition, the movies that we've watched in this case don't have any specific order, so we don't care about the order, and therefore a set is a perfect structure to put these movies into. Then we are going to ask the user for a movie they've watched recently. And finally, we're going to print whether the movie is in our movies watched. If we run this, then you'll see that if we type the matrix, you get true, but if you type Monty Python, then you'll get false. The in keyword works in sequences like lists, tuples, sets. It also works in strings, actually, so you can check whether a string is inside another string, such as a substring. For example, RIX would be in the matrix. So you can do checks like that as well if you want. Let's move on to the next video where we're going to learn how to use if statements with this syntax here so that we can create even more powerful programs. I'll see you there. Hi guys, and welcome back. In this video, we're going to look at some if statements with the in keyword and also a few more examples so you get a bit more experience. Here we've got our movies watched, which is a set of strings with the movie titles, and then we're asking the user for a movie they've watched recently. We can then say user movie in movies watched, and we can put that in an if statement. So again, when Python reaches line 4, it's going to evaluate this Boolean and it's going to say, is the thing the user entered one of the elements of this collection, this set? And if it's true, then it's going to evaluate this code here. And remember, we need indentation in front of this so that Python can tell what code is inside the if statement. So we're going to print something like, I've watched user movie 2. Otherwise, we can print, I haven't watched that yet. If we run this, then you can enter something like Green Book, and it'll tell you that I've watched Green Book 2. Of course, if you enter something else, then it'll tell you that I haven't watched that yet. So this is how you can use the in keyword in an if statement. And it just works in exactly the same way as it did in the last video when we were printing it out, but now you can use it there in order to make decisions and potentially do different things in your program. Let's work on a slightly different example. We're going to create now a magic number app. So in this application, we're going to decide on a magic number, a hidden number from the user. We're going to ask the user to enter a number, and then we are going to tell the user whether they got the number right or not. But before we do that, we're going to ask the user whether they want to play the game or not. So we'll start by creating our magic number. We'll say number equal 7. Then we're going to ask the user whether they want to play. So we'll say user input equal input, enter y if you would like to play. Now we're going to say if user input equal y, then we will ask them for a number. So we can do something like user number, int of input, guess our number, let's say. So we will ask them to guess our number, we will get the input that they type, and then we will turn that into an integer. And finally, we can use another if statement here and say user number equal number. Then we will print that you guessed correctly. Otherwise, we will print, sorry, it's wrong. So we're not using the in keyword here at all, but there are a few things that I wanted to tell you about before we do that. The first one is that all of these lines are inside this if statement. So they will only ever potentially run if this is true. So if the user enters lowercase y, then we will start running this line. Number 5, then we will move on to 6, and so on. Number 6 here is another if statement. So if this is true, then we will run this line. And now you can see that this line has 2 sets of indentation because it is both inside this if statement and this one. So therefore we have 4, 8 spaces in total in front of it, so that Python can tell that this one belongs inside this if statement. Then we've got an else paired with this if statement in line 6, which means that if the user number was not exactly correct given our magic number, we're going to print, sorry, it's wrong. And again, notice the indentation in this line. We can run this code and then we'll ask the user to enter y if they would like to play. So we're going to enter y and then we can guess the number, let's say 7, and you can see that we guessed it correctly. Now let's start using the in keyword, because the first thing that you may see users do is that they may think that because this is a computer or something, they have to enter uppercase y. It is quite common in computing to ask the user for uppercase letters, so they might do that. And here you can see that we don't support this uppercase variant. So there are 2 things you can do. The first one that we've already looked at is you can turn this into lowercase, and that is actually the better choice of the 2. So I would do this. I would turn the user's input into lowercase, and then I would compare the lowercase user input with the lowercase character that I want to check. But in some situations, you may want different options potentially, or you may not want to do that exactly. So there is something you can do in this if statement, which is to replace the equal for in, and then you can have here a tuple of the 2 letters that you're willing to accept as your input. So what we do here is we create a tuple with 2 strings, lowercase y and uppercase y, and then we're checking whether the user's input is one of those 2. And if it is, then we will proceed. So this is something you could do if you were interested. I'm just showing you that there, but I would actually prefer to turn the user's input into lowercase. The second place where we could use the in keyword is if we wanted to give the user a hint regarding how close or how far they were from our magic number. So let's say that we want to tell the user that they are off by 1 if they enter 6 or 8. Here in the if statement, after user number equal number, we're going to say elif number minus user number in 1 and minus 1. We're going to print you were off by 1. So what this is doing is, once again, it's defining a tuple of 2 numbers that we're willing to accept, 1 and minus 1. Then we're going to subtract from our number, which is 7, the user number. Let's say 6 as an example. 7 minus 6 is going to give us 1, and then it's going to check whether 1 is in this tuple, which has 1 and minus 1. If it is, then we're going to print that you were off by 1. If they enter 8, then we will do 7 minus 8, which is minus 1, and minus 1 will also be in this tuple, so we will also print you were off by 1. This is something you could do, and potentially this can be really handy if you want a longer set of values. But for this specific situation, there's also a better way of doing it without the in keyword, which is by using absolute values. So you can do ABS of number minus user number. And what ABS does is it gives you the absolute value of this argument. So if you pass it the value 1, ABS of 1 will give you 1. But if you pass it -1, ABS of -1 will give you 1. It will turn it back into positive. So now number minus user number will always give you how far away the user was from our magic number in positive terms. So you can go back to saying equal 1, because this number here will always be 1, 2, 3, and so on. So if they were off by 1, then we can just print that. And I think this is a slightly better approach than using the in keyword, but again, the in keyword can be useful in a wide number of scenarios where this may not be enough. If we run this again, you'll see that we can type Y to play. Then we can guess the number, let's say 8, and then it says that you were off by 1. Feel free to play around with this code and change it and do more things with it if you'd like. This is a great exercise and will be good practice for you if you're starting to learn to code. Thanks for joining me in this video. I hope it's been useful, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about loops in Python. There are two types of loop. One that allows us to repeat some code a certain number of times, and one that allows us to repeat code for as long as a condition is true. Let's start with that one in this video. So we've got our code from the last video here, where we ask the user whether they want to play, and then if the user's input was Y, we asked them to guess our number, and then we told them whether the number was correct, the number being defined up here. Now what we're going to do is we're going to repeat the game over and over until the user asks us to stop. So what I'm going to do is I'm going to change this prompt a little bit before we begin, and I would say, would you like to play? And then I will give them the options of Y in capital or N in lowercase. This is a common convention in terminal-based programs where you use one of the options as uppercase and one of them as lowercase, and that means that if they type anything other than N, Y will be the default. So they have to specifically type N if they want to stop. This is a common convention, so you can use this in your own programs as well. What that means is that now we want to repeat this code here, allowing the user to guess a number and then telling them whether it's wrong or not, for as long as the user didn't type N. So if the user types anything except N, we want to run this code. So we no longer need this if statement there. But what we want to do is we want to use a while loop. So we will say while the user input is not N, so while user input is not N, then we will repeat this code over and over. What happens here is that we've got the while keyword, then we've got a space, and then we have our condition, more or less like the if statement we had earlier on, but now this code here makes the indented code run over and over, and what happens is it starts up at the top and it goes to the bottom, and then when it reaches the end of this block that's indented, it goes back to the top and evaluates this Boolean again. So if this Boolean is true, then it will run this again, and then it will go back to the top and evaluate the Boolean again, and so on. Of course, the first time that Python reaches line 4, this Boolean is also evaluated, so potentially the user could enter N to begin with, and then this loop would not run at all. So that is how the while loop works. Now, of course, if the user enters Y, then Y would not be equal to N, that's true, so this would run. And then we will go back to the top, and this would still be Y. And it still wouldn't be equal to N, so this would run again, and so on forever. If you don't change the condition here, then you're going to end up in an infinite loop. So what we have to do to begin with is we have to ask the user whether they want to play again. So what we'll do is we will copy this line here, just for now, and we will put it inside the loop, but not inside the else. So just down here in the same indentation level as all the other lines, we ask the user whether they want to play again. And what that means is that when we go back to reevaluate this condition, the user can potentially affect that and potentially terminate the loop. However, there is a small issue in here, which is that you have these two lines duplicated. So if you ever want to change your prompt, for example, you're going to have to change it in both places, and that can be a little bit cumbersome. So instead what we're going to do is we're going to get rid of it and introduce another Python keyword that allows us to do that. Here, I'm going to change this so it no longer uses the condition. Instead, I'm going to do while true. This always creates an infinite loop. So now this code will run, and then we will go back to the top. This is still true, so it runs again, and so on forever. If you use while true, then you must be able to terminate the loop from within the loop's code. So what I'm going to do is I'm going to move this line into the loop. And then after the line, I'm going to say if user input is equal to n, and here comes the break keyword. The break keyword allows us to exit a loop. So because we're inside a loop here, we can break out of it, and that terminates it and continues our Python code from the next line after the loop. So what we've done here is within the loop, we ask the user whether they like to play, and if they type no, then we terminate. And if they type anything else, then we continue with the loop. And that happens over and over. This is an alternative way of doing the loop that you saw just a moment ago. You can do either. This one does reduce duplication, but it adds an extra if statement inside your loop. So it's up to you which one you want to do. Usually though, I would go for something like this. That's everything I wanted to show you regarding the while loop, so let's take a look at the for loop. Let's say you've got a list of your friends, Rolf, Jen, Bob, and Anne, and you want to print out a simple string for each friend. For example, you want to print out Rolf is my friend, Jen is my friend, Bob is my friend, Anne is my friend. The simple way to do that without loops is of course to do something like print friends 0 is my friend, and then repeat that for 1, 2, and 3. Obviously, as the list of friends grows, this gets increasingly difficult. Plus, if you have this list as part of a program and you want to be able to print out that all your friends are your friends, you're not going to be able to do that without changing the code. So here's where the loop comes in handy. We're going to repeat this structure for each of your friends. So what we'll do is we will say for friend in friends, and then we will indent this piece of code, and here we will use the variable friend. How the for loop works is you have the for keyword, then you have your space, then you define a variable that will take the first value of this list, so Rolf, and then you have in friends. That's the list that you want to go over. And what this allows you to do is to use this variable and make it equal to the first value in this list, and then run this code. When you reach the end of the indented code, it goes back to the top, and friend takes the second value. And then it runs this code, and then it goes back to the top, and friend takes the third value, and so on. When you reach the end, the for loop structure knows that you are done, and then it continues running the Python code from the next line onwards. So this is great when you want to do something for each element in a list or a tuple or a set and so on, and also when you want to repeat something a certain number of times. For example, here you know you have 4 elements in this list, so therefore this loop will run 4 times. If you wanted to run a loop 4 times and you didn't care to create a list of 4 elements, you can actually do for variable in range 4. And that is also going to allow you to repeat this code 4 times. Of course, the friend variable still is used. So if you run this code, you'll actually see that you get back 0 is my friend, 1 is my friend, 2 is my friend, 3 is my friend. Because when you do range 4, that creates something like a list where the first element is 0, the second one's 1, and so on. This is a construct that allows you to iterate over a list of numbers so that you can repeat the code a certain number of times. Usually though, for a for loop, you'll be using something like an existing list and do something with each element. Let's use a for loop to calculate the average grade of this class. So let's say we've got a list of grades where the numbers are 35, 67, 98, and 2 100s, and we have a variable total which is equal to 0. Then we also have an amount of grades, which is the length of the grades list, which gives us 5. What we want to do is use a for loop to modify this total variable and add to it each of these grades. How we do that is we say for grade, for example, in grades, and that creates a new variable that we're calling grade, although you can call it whatever you want, and it's going to help us go through each of the values in the grades list. Then we will say total plus equal grade, and this, by the way, I think we've not seen it before, but it's the same as doing total equal total plus grade. So it adds up the existing total plus the new grade and sets it back to total. You can do that, or you can do plus equal, it's the same thing. And then, after the for loop, once we've added them all together, we can print out the total divided by the amount, and that's going to give us the average. So if we run this piece of code here, you'll see the average is 80.0. Now I'll say at this point that you don't actually need a for loop for this specific piece of code, and this will help me introduce another function in Python, which is the sum function. Instead of doing all of this, you can actually say that the total is the sum of grades. Just as we have len to calculate the length of a list, sum calculates the addition of all the elements inside a list, or a tuple or a set, and so on. So here we have the total and the amount, and this does exactly the same thing without the need for a for loop. So you just kind of have to know that this exists if you want to use it, but my advice would be to pretty much search for everything in Google or your search engine of choice. I would search, when I was starting, for how to add a list of numbers in Python. And that'll give you many answers, and one of them will teach you about this sum function. When you're doing anything else in Python, usually I would also search for everything. And that way you're going to be constantly absorbing new information and learning different ways of doing things. It's very often that programmers will try a very complicated solution at first because that's what we can build based on the building blocks that we already know. But there's usually better solutions out there, and by searching for them, you're going to be able to absorb that knowledge, as I said. That's it for this video, though. Thank you for joining me, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about list comprehensions in Python. A list comprehension is a great feature of Python and allows us to create new lists on the fly from existing lists. In addition, it's very succinct and very powerful. Let's get started. Here we've got a list of numbers, and I want to end up with these numbers but multiplied by 2. So I'll say something like doubled equal empty list. How do we put each of these numbers multiplied by 2 into this new list? Traditionally, and in most languages, you would end up doing something like for num in numbers, and then you would do doubled dot append num times 2. This is quite a long piece of code just for creating a new list of doubled numbers, but this is how you do it normally. You would iterate over the numbers list, create a new variable for each of the numbers in it, and then run through it 3 times, each time putting the appropriate number multiplied by 2 into your new list. Python has a much more succinct way of doing this, which is with a list comprehension. In a list comprehension, the order of these operations, first the iteration and then the appending, seems to be reversed, but it's not really. So the first thing you do is you would put in what you want to add to your new list, which is num times 2. But of course, num doesn't exist in this context. It only existed here because we've got our for loop. So the next thing you do is you put your for loop. And what this does in Python is it puts num times 2 into a new list for every num in the numbers list. So essentially you're iterating over the numbers list and you're putting the variable multiplied by 2 every time that the loop runs into your new list. You end up with the doubled numbers. Because list comprehensions are usually in a single line, you do want to keep them short if you can. So instead of num times 2, for example, in this case, you could do x times 2 and for x in numbers. That just helps you keep it a little bit shorter and a little bit more readable. After all, the most important thing here is that you're putting x times 2 into your new list while you iterate over the previous list. So again, to recap, how you build a list comprehension is what you want to put into your new list for the variable that you're using in numbers. Now let's say you've got a friends list and you want to create a new list which contains the names of those friends that start with an S. So Sam, Samantha, and Sarab. But it seems that a list comprehension may not be the tool for this job. After all, you do need to only get some of these out. Let's start with a for loop, and then I'll show you how the list comprehension can deal with it. So you would do for friend in friends. Then you would add an if statement to check that the friend name in question starts with an S. You can say if friend.starts with capital S, then you're going to do starts s.append friend. And then at the end, we're going to print starts s, like that. Let me run this and show you what happens. Down here you have Sam, Samantha, and Saurab, and I think I'm not pronouncing that right, so my apologies if that's the case. So what we've got is a for loop, and then an if statement, and then an append. This structure here can also be reproduced with a list comprehension, although it does start to get a little bit more confusing. Again, the process is more or less the same. First of all, you put what you want to add to your new list, so that's your friend name. Then you put your iteration or your for loop for friend in friends. And now if you want to add an if statement, you do it at the end. So you're going to add your friend for the friend in your list if the friend starts with S. And that does exactly the same thing, and you no longer need that loop there. So you can save that and run it again, and you see that the same thing comes out. So this is how you add a conditional, an if statement, into a list comprehension. It's very important to notice that when you use a list comprehension, a new list is created. So even though these two lists may be the same, if we take these names out, so now these two lists will be the same. If we print them both out, you'll see that they are both identical. When you print friends is starts S, you'll see that false comes out. That's because these two lists, although they have the same contents, are not the same list. They are two different lists, two different places in your computer's memory with the same values. For context, friends 0 is starts as 0, so Sam is Sam will give you true. See that? But the lists themselves are not the same. So the elements inside them are the same, but the lists themselves are not the same. And by using the is keyword, then you can check that. But there's also something else you can do, which is check the IDs of these lists. So you can do something like friends, and then print out the ID of friends, and then starts S, and print the ID of starts S. And what I've done here, by the way, is I have passed multiple different things to the print function, and you can do that in print, and it just separates them with a space. So it's going to separate these different parts with the space, the different arguments there. So by running this, you get that friends has an ID of this, ends in 2096, and starts as has an ID that ends in 5280. So these two have different IDs, and in CPython, which is what most of you will be using, certainly what I'm using, the ID is related to the memory address in which the list is stored. So you can see that these two things are in different places in memory, they're different objects entirely, they just happen to have the same contents. So this is something that will be very important as we proceed with the course. So this is why I wanted to show it to you at this point. Creating new lists gives you a different thing entirely in Python. It's not the same as the thing before, even if it has the same contents. But as I mentioned earlier, if you do want them to be the same exact list, then you can do this. Starts as equal friends, and now when you press play, you'll see that you get true, and these IDs are identical. So that is how you make two lists the same thing. Otherwise, you do end up with two different lists. Alright, that's enough of that. Thank you for joining me in this video. I hope it's been useful, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about dictionaries. Dictionaries are another structure in Python, like lists, sets, and tuples, that allow us to interact with data in a certain way. And what dictionaries are for is to associate keys and values together, so that if you know the key, you can access the value very easily. For example, you could have a dictionary of your friend names being the keys and their ages being the values. That way, if you knew the name of your friend, you can very easily get the value out, their age. Let's get started. Let's say we have a dictionary friend ages, and it's equal to the curly braces, and inside it you've got your friend name, Rolf, and then a colon, and then something like 24. This is a dictionary of a single element, where the element is this key-value pair. The pairing is done with the colon, and that means that 24 is a value associated with the key Rolf, which is a string. Keys must be strings, they can also be integers, and any other hashable types. Now, I know we haven't talked about hashable types yet, but for now, just think of them as integers and strings. If we want multiple values in a single dictionary, you can separate the key-value pairs with a comma. So we can have Adam 30 and Anne 27, for example. And here we have a dictionary with 3 values, 3 keys, Rolf, Adam, and Anne. And each of those keys has a value associated with them. Rolf has 24, Adam has 30, and Anne has 27. If you wanted to access one particular element, you can do friend_ages, and then using subscript notation, access the appropriate key. So in here we could put, for example, Adam, and then we would access the Adam key inside the friend ages dictionary. Remember that in lists and tuples you could use subscript notation to access a particular index, such as 0, 1, and 2, but that won't work in dictionaries. You must access the keys themselves. Of course, if we print this out, you'll see that we get 30 out. Just there. If you wanted to change a particular element or add one, you can do that by doing friend ages, and then, for example, Bob equal 20. Then if you print friend ages, you'll see that Bob will have been added to the dictionary. So when we print it out, we've got Rolf, Adam, Anne, and Bob. And if you want to change one, just do the same thing, but with an existing key. And now Rolf is 20. So that is how you can add a key, just access it and set a value to it, or change an existing key. Usually when we're working with dictionaries that are used to represent multiple things in the real world, such as multiple friends or things like that, it's quite convenient to have a list of dictionaries. For example, let's make a list of our friends. Now, in the past, we've had a list of friends such as Rolf, Adam, and Anne, like this. But you can actually have a list of dictionaries, each dictionary describing a friend. By the way, I'm not sure if we've looked at this split syntax for lists, but lists don't care about whitespace, so you can put multiple values in one line, or you can split them across several lines, however you like. Going back to our dictionary, you can, instead of Rolf, create a dictionary that contains name and Rolf associated with it, and age and 24 associated with it. Now, if we do this for each of our friends, and I will do that with Adam and Anne and their appropriate ages, that means that now what we've got is a list of dictionaries, and each dictionary represents a friend. But that means that we can store more than just their name in each element. Before we were constrained to just storing their name in our list, but now we can store more data if we want. If you print friends out, you'll see that you get back your list of friends there. And of course, if you wanted to print a particular friend, you would need to use the index, because this is a list. The friends list needs to be accessed by index. So if you wanted to access index 0, that would give you back this dictionary. Index 1 would give you this dictionary, and index 2 would give you this dictionary. So let's say we want to access index 1, which is this dictionary. If you print this out, you'll see that what you get back is naturally the entire dictionary. That means that now, after friends 1, you can put another subscript notation to access the name, for example. And doing this will give you Adam. So this is how you can access a list of dictionaries, or a particular value inside a list of dictionaries. If you had a list of lists, you would access multiple indices in succession like this, and if you have a dictionary of dictionaries, then you would access multiple keys in succession. Let me say, of course, that you can nest these lists and tuples and dictionaries however way you want in Python. Let's take a look at another example where we have a dictionary that maps their student names to the percentage of attendance they have to their lessons. So Rolf has attended 96% of his lessons, Bob 80%, and Anne 100%. You can iterate over a dictionary using a for loop, and what this does is it gives you the keys. So if you print this student variable that we're using here for iteration, what you get back are the student names, the keys in your dictionary. Using that key, you can print something like this, which will print out the student variable, which is the student's name, and then you can access the student key in the student attendance dictionary using subscript notation to get their attendance. So if we save this and run it, you now see that we get Rolf 96, Bob 80, and 100. You can of course put a percentage sign there if you like to make it a little bit nicer. However, accessing a dictionary like this in a for loop doesn't look the best because there are other better ways. The better way is if you do student attendance dot items, and then here you can do for student, comma, attendance in student attendance dot items, and then here you no longer need to access a dictionary because you've got it in the attendance variable. So what we've got here is that student attendance dot items gives you two values for each student that you can get as two separate variables here in Python. Saving and running this will give you exactly the same as before. You can use the in keyword in a dictionary to check whether a value is one of the keys of the dictionary. So for example, if Bob in student attendance, you can print something like Bob attended this many lectures. Otherwise, you can print that Bob is not a student in this class. So the in keyword allows you to check whether a value is one of the keys. Notice that you can't check whether one of the values is in the dictionary, you can only check the keys. Finally, you can also get just the values back if you like. If you wanted 96, 80, and 100 without worrying about the keys, for example, if you wanted to calculate an average, you could have a variable called attendance values and make it equal to student attendance dot values, and then you can print the sum of attendance values divided by the length of attendance values. And what this is going to give you is add 96, 80, and 100 together and divided by 3, which is the length of what you get back, which is a list. So if you run that, you get back 92.0. Going back to what we had earlier, which is this syntax where you have two variables being defined separated by a comma inside a for loop, we're going to learn more about that in the next video. So if that's unclear, don't worry about it. We'll look at it just now. I'll see you in the next video. Hi guys and welcome back. In this video, we're going to learn about destructuring variables, which is something we looked at in the previous video in the for loop, but now we're going to explain how it works. Normally in Python, when you assign a variable, you can do something like x equal 5, say. But you can also do x equal 5, 11. And this here is a tuple. We've learned about these in the past. But what a lot of people don't know is that the brackets are not necessary. The brackets are only necessary when Python might be confused as to whether you want to create a tuple or these are values in another collection. So if you have a tuple like this one, you can actually remove the brackets. But if you wanted to create a list with a tuple inside it, then you would need the brackets, because if you don't put the brackets in, you'll actually end up with a list with two values, not a list with a tuple inside it. So the brackets are only needed when you want to explicitly say, I want a tuple here, I don't want Python to treat these as two separate values. But most of the time, the brackets are not necessary, so you can leave it as this. Now, regarding destructuring variables, this tuple here can be destructured or decomposed or split out into two variables if you want. X comma, y. And Python is smart enough to assign x to 5 and y to 11. It's just a shorthand instead of defining two variables separately. The extra benefit that we get from being able to do something like this is that if you have another tuple, which is 5 and 11, you can then actually say something like this, x comma y equal t. And then we can print x and y. So if we run this, you'll see that you get 5 and 11 as the two separate variables. So Python was smart enough to say, okay, t is a tuple, and you're asking me to assign this tuple to two variables. What I'm going to do is I'm going to split it out into its components. So this is what destructuring really means. In the last video, we had some code like this one, where we have a dictionary of strings to integers, and then we iterated over student attendance.items. Now I'm going to print the list of that, which is going to take this stuff here, turn it into a list, and print it out. So let me do that and not print that, and show you what happens. Notice that what you get back is a list of tuples. So if you iterate over a list of tuples, that means that by doing something like this, what you are getting is 3 different tuples. Let me show you what happens. If I say that, and then I print t there, and then I comment that out, you can see that t is first a tuple of Rolf and 96, then a tuple of Bob and 80, and then a tuple of Anne and 100. So instead of t, we can access its components because we can destructure this into 2 separate variables, and that's what we were doing earlier on when we destructured the tuple into student and attendance. Student would be Rolf, and attendance would be 96. And then the next time you go through the loop, you'd get the next tuple, and that would be destructured into its 2 components again, and so on. So that is why this works. Hopefully that makes sense. That is destructuring in use here in a for loop, and you're going to see it quite a lot when you do something like items, or when you use something like the enumerate function that I know we haven't spoke about yet. It is quite prevalent in Python. I'm going to link a blog post on destructuring variables that you can read as well if you'd like. Let's take a look at another example. Here we have a list of people where instead of a dictionary, each person has a tuple with 3 values: their name, their age, and their profession. Because we've got a tuple of 3 values, we can do for name, age, and profession in people. And that is going to, once again, iterate through each of the tuples, and for each one, destructure it into its 3 separate components. So here, we could print a nice string describing this person. Just like that. Notice that if any one of your tuples is missing a value, you're going to encounter some problems. It says value error, not enough values to unpack. So you try to access 3 values of this tuple, but there weren't 3 values, profession was missing, so you get this error. So this is something you have to be careful with when you're doing this destructuring or unpacking. Notice that the alternative to doing this is to iterate over each tuple and print out each thing using indices. So person 0 would be the name, person 1 would be the age, and person 2 would be the profession if you don't destructure the variable here. So this is clearly much less readable, it's not as obvious what's going on, so destructuring these things does help your code look a bit nicer. Let's say you got a single tuple and you want to extract a person's name and profession, but you don't care for the age. In Python, variables can contain and even start with an underscore, and that is frequently what's used as a variable when you want to ignore one. So you can say name underscore profession equal person, and what this is going to do is it's going to create 3 variables, name, underscore, and profession, and Bob will become name, 42 will become underscore, and mechanic will become profession. But the underscore on its own is so bad a variable name that nobody would want to use it unless it was not meant to be used. So that is what the Python community has decided, that if you use an underscore variable on its own, that is because you don't care about this variable. This variable is meant to be ignored. So then it's just as good to print name and profession out if you wanted to just print the person's details out. Let's say you've got a list of 5 elements, 1, 2, 3, 4, and 5, and you wanted to separate this into 2 lists, the first element and all the other elements. Well, you can do head, comma, star tail. And that is the syntax for collecting. So what you're doing is you are collecting all of the destructured values into this variable. All of the values that don't match any of the other destructured values, which in this case you've got the head. So the first value in here will become the head, and then this syntax here will collect the other values and will put them all into tail. So if you print head and you print tail, then you'll see what happens is you get 1 as the first value and 2, 3, 4, and 5 as the second value. Notice that you only need to do this when you want to put all the values into one place. You never need to use it again like that. You don't have to do that. Instead of that, you can move this, of course, and put the star at the front if you like, and then this is going to collect as many values as possible, but leaving room for the tail, which is going to be the last one. So head will be 1, 2, 3, 4, and tail will be 5. Just like that. The asterisk can also be used here. We're not going to learn about that just now. We're going to learn about it in a few videos' time. It's a little bit more advanced, so I want to get into some of the other topics before we talk about that one. So please do bear with me. I know that that will work if you do that, and it will print out something slightly different. Not printing the list anymore, now it's printing the separate values, and that is valid Python, and you will use it quite a lot as you program in Python, but again, we're going to learn about it in a later video. So please bear with me. I hope this video has been useful, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about functions. We've been using some functions, such as print and len and sum, but now we're going to be defining our own. And that means that we can put some bits of code and give them a name, so that we can reuse those bits of code whenever we want. Let's learn more about them. I'm going to create my first function, and I'm going to call it hello. So you start off by using the def keyword, and then you type out the name of the function you want to define. Then you put a pair of brackets and a colon, and that begins the function body. Here we're going to put print hello. And what happens now is that we have a function created. When Python reaches a def keyword, it then says, okay, we've got a hello variable that we are creating. Only this variable is not a normal value variable like a string or an integer. This is a callable variable. That means that it's a variable whose value is a function. And a function you can call or execute. Calling, running, or executing a function are all synonyms, so they mean the same thing. So when you define a function, you create a callable variable. Now, creating the function or defining the function does not run the function body. It just tells Python that a variable called hello exists. So if you run this code, nothing actually happens. As you can see down here, nothing is printed out because the function has been defined, but the function has not been called. So in order to call the function, you have to type out the variable name, which is hello, and then the brackets. And these two brackets after a variable name is what actually calls the function and executes it. The order of running these lines in Python is as follows. First, line 1 runs and tells Python to create this hello variable that is a callable. Then line 2 does not run. Line 3 runs, but it's empty. And then line 4 runs, which tells Python to execute this function. So Python jumps back up and then runs line number 2. Notice that Python knows line number 2 is part of the function body because, of course, it is indented. So it's got these 4 spaces in front. You can put more lines inside the function as long as they're also indented if you want. Let's define another function. Here I've created a callable variable, user age in seconds, and it is a function. And now we can put some code inside of it. So I'm going to implement the first app that we coded earlier on. So user age is going to be int of input, enter your age. Here we ask the user for their age, and then we're going to turn it into seconds so that we can print it out. So age in seconds is going to be user age times 365 times 24 times 60 times 60. That is years multiplied by days, hours, minutes, and seconds. And then we're going to print it out. Just like that. Of course, just to reiterate, if we run this, nothing happens. You do have to call the function user age in seconds. And if you do that, you can actually type down here. Let me repeat at this point that sometimes I'm pressing the play button and other times I'm running the code in the terminal because pressing the play button does not allow you to type. So you have to run this code in the terminal if you want to type. Let's enter the age, such as 30, and then we get your age in seconds is that. Now, one of the benefits of doing this is that what you have now are two reasonably separate bits of code. One, which is what the code does, and the other one, which is the code that will actually run. Now, this is very much a conceptual separation. So the code is really just a single file which runs line by line and so on, but conceptually, as a person, you can think of it as running the code and defining the code. So it can help you understand and read through your code a bit better if you make that conceptual separation. For example, here we're running the code, so we could actually add some more things. Such as that. Now, if we run this again, you get a nice message, and then you get your goodbye there. But as I said earlier, these lines here are just running from top to bottom. So you can move that line to the top if you want. And you can put this line anywhere you like. And Python will still print out the exact same stuff. Welcome to the age in seconds program will be printed out first. Then the user age in seconds will be printed out next, which runs through this function. And finally, goodbye will be printed out after. However, by treating these two as slightly separated parts of code, it can actually be much easier to reason about, much easier to read, and much easier to think about. So that is just a tip there from me to you. A couple of things that you should not do when you're working with functions is reuse names. So if you define a function called print and then you try to print hello world, you're going to get a problem. Because when you define the print function, that creates this print variable that you can use, and then you are actually using it. Here, this is no longer the Python built-in print function that we're calling. This is calling your own function. And this is almost never what you want, although it is valid Python code, it's almost never what you want. And another reason why you get an error by doing this is because you're putting in a string inside the brackets, but this function cannot take in a string. We're going to learn how to do that in a future video. So if you run that, you're going to get an error. It says print takes 0 positional arguments, but 1 was given. That means that we've put a string in there, but our function does not accept a string. Another thing that you may want to avoid is, imagine you've got a list of your friend names, and then you have a function that adds a friend. Then you take in the friend name from the user's input. And then here's something that you almost definitely want to avoid, and that is to say friends equal friends plus friend name. What's happening here is you're reusing the friends variable in two different places. And because you are inside a function, Python actually creates a new space for variables that is separate from the global space. So functions have their own little space for your variables. And when you do friends equal, Python is creating a new variable called friends that only exists inside the function. The same thing with friend name. So you now have two variables, friends in the global scope of the file and friends in the function scope of this addFriend function. This is almost never something you want to do, because even though you are using a variable called friends, you are also defining a new variable. So let me run this here. So let me run that, and you can see that if I enter Rolf, you get your error here. And what's happening is that this variable exists, and if you call this something like f, then this code is fine, because Python will see the friends variable, it will check whether it exists inside the function, but it doesn't, so it uses the one outside the function. So that's fine. But as soon as you do friends equal friends plus friend name, Python is going to look at this friends variable and notice that it's been defined inside the function. And you can't do that because you can't use a variable in the same line where you're defining it. It doesn't make sense. So it will give you this error. It's akin to doing x equal x plus 5, but x doesn't exist. So Python will also be very confused if you do that. All right, so almost never will you want to shadow a variable name from an outer scope. That is a technical definition for what we're doing here. We are shadowing the friends variable by redefining it inside a function where it already exists on the outside. Again, this is valid Python code. Of course, this is not, because you're using the variable in the same line you're defining it, but generally shadowing a variable is valid Python code. It's just something that you usually don't want to do. Something else you can't do with functions is use them before they get defined. Maybe this is obvious, but here we're calling the function, say hello, and then we're defining it down here in line 4. Python won't let you do this. If you try to do that, you get an error saying that the say hello name is not defined. Here we've got a final example where we have an add friend function that takes in a global variable friends and appends Rolf to it. Then we define the friends variable in line 5 after the function has been created. Then we call the function add friend, and finally we print friends. So this may look like an error because here in line 2, the friends variable has not yet been defined. But actually remember that this line of code only runs when line 6 runs. So this is fine, although a bit confusing. The friends variable that this uses will be defined by the time this line is ran. So that's why this will work, although it will be quite confusing, as I said earlier. Usually you'll want to put your global variables at the top so that it's a bit clearer what's going on. Also, this line here is modifying the friends list. So if you call this function multiple times, it's going to append Rolf to this list multiple times. So that's something interesting about this function here, that you are appending to this list, so you'll end up with multiple elements if you run the function multiple times. Alright, that's everything for this video. I just wanted to show you what functions look like in Python, how you define them, how you use them, and some things that you don't want to do when you're working with functions. Thanks for joining me in this one, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about function arguments and parameters. That is, how we can give our functions data so that they can use it. For example, the print function makes use of this so that it can accept a string to print out into the console. We're going to learn how to do that in our own functions. Let me define a function that has two parameters. What I've done here is I have created a function called add, and inside the brackets I've put the names of its two parameters. So that's x and y. Notice that I have put the word pass inside the function body, and what that means in Python is do nothing. It is needed, at least something is needed inside a function, because Python expects the indented block there. So that's why I've put that there, but it doesn't mean anything. We've got our two parameters here, which are x and y. We have two parameters because they are two variable names separated by a comma. And what happens is that when Python runs the function, when you call the function itself, these two variables are created and the function can use them inside the function body. When you get to the end of the function body, the variables disappear. So what are the values of x and y? Well, that depends on what you give the function when you call it. So for example, if you add and put 5, 3, then these here are called arguments. These here are called parameters. So each argument provides a value to one parameter. 5 is the value of x, and 3 will be the value of y. Of course, our add function doesn't do anything just now, so we are going to make it do something. We're going to say result is x plus y, and then we're going to print result. So now we have here our function with two parameters, and then our function call with 2 arguments. When the function call happens, these values get placed into these variables, and the function runs. So here result will be 8, and then we will print that out. So let me just run that for you, and you can see that 8 comes out down there. Let's do another example. Now a function without any parameters. So if we have a function such as this say hello function that doesn't have any parameters, notice that the brackets are empty, you cannot give it arguments. So if you type say hello and you pass in Bob, this will fail in Python because you are passing an argument to a function that has no parameters. So if we run this, you'll see that it says say hello takes 0 positional arguments, but 1 was given. We haven't looked at what positional arguments mean yet, but Bob is a positional argument. More on that later on. So we've given this function 1 positional argument, but this function doesn't take any. It doesn't have any parameters, so that's why the error happens. Similarly, if we instead decide to pass in a name and we do something like this, now you can call the function with an argument. So if we run this, you'll see that we get hello Bob, because this function prints the string hello with the name variable inside it. But having a parameter means that you must pass in an argument. So you cannot call the function without an argument. If you do, it says that say hello is missing 1 required positional argument, and then it gives you the name of the positional argument. So it's saying that you need to pass in a value for this name parameter, but you didn't, so you should. So when you put Bob in here, we've said that this is a positional argument. And the reason why it's called a positional argument is because if you have multiple arguments, such as these 2 here, and then you call it like that, the only way Python has of determining which parameter takes which value is by position. So Bob is the first argument, or in the first position, so the name parameter will take the value of Bob. And Smith is the second argument, so the second parameter will take the value of that. So these are called positional arguments because the position they're in will affect the value of its relevant parameter. However, Python also has arguments that are not positional. They are called keyword or named arguments. For example, you can do surname equal Bob and name equals Smith. And now Python will be able to tell that you want the surname parameter to take the value of Bob and the name parameter to take the value of Smith. These here are named or keyword arguments. Named or keyword arguments are really helpful because they allow us to very easily determine when we are reading this line here which argument is for which parameter. And indeed, if we hadn't come across this function before, it would also tell us, what the function does to some extent. If you read this line here, you can see that, okay, you're going to say hello, and you're taking a name and a surname, so you're probably going to print that out. That allows you to make some inferences about what this code is going to do. So this can be really helpful, and it's very widely used in Python. For example, let's say that you've got a divide function where if the divisor is not 0, then you're going to print a dividend by the divisor. Otherwise, you're going to print something like you fool. You can't divide something by 0. So we've got a function here. Then you can call this function divide with something like 15 and 0. So this may be okay. You can press play and you get back you fool. However, it can be clearer if you tell the reader of this line which value is which. Now, with something like division, it may be obvious that 15, 0 is going to divide 15 by 0. That seems reasonable to a reader, I think. But again, it can be clearer if you say dividend is 15 and divisor is 0. Notice that usually in Python, we do not put spaces around this equal sign here when it's being used to separate a value from its keyword argument. As well as passing dividend and divisor like this, you could reverse them, put the divisor here and the dividend there, and that would be fine, although maybe a little bit more confusing. But also, not all arguments have to be keyword arguments. You can have some positional arguments and then some keyword arguments. But that's exactly it. The positional arguments have to go first, and the keyword arguments have to go later. If you do dividend equal 15, and then you skip the keyword argument there, you're going to get an error, and Python is going to tell you that a positional argument follows a keyword argument, and that is illegal in Python. So the positional arguments have to go first, keyword arguments go later. I recommend that you use keyword arguments whenever possible, just because they're going to make your code a little bit easier to read, unless it's really obvious what's going on. So, for example, in a divide function, maybe you don't need the keyword arguments. Similarly, in a say hello function that just takes a person's name, you probably don't need keyword arguments either. But as soon as you start doing more complicated things or functions that are maybe not as obvious, using keyword arguments is really going to help. So I recommend that you use them. That's it for this video though. Thank you for joining me in this one, and I'll see you next time. Hi guys, and welcome back. In this video, we'll learn about default parameter values in Python. Let's get started. We've got a function here called add, and it takes two arguments, so it has two parameters, x and y, and then it's going to print the result of adding them together. So normally, you would call this add function with two arguments, so 5, 8 gives them 5 and 8 to x and y. However, you can have default values for one or two of these parameters by just saying in the function definition y equals 8, say. Again, we usually don't put spaces around this equal sign when we use it for a default parameter value. And what this means is that x is a required parameter and y now is an optional parameter. If you don't give y a value when you call the function, it will use the value 8, which is defined here. So instead of doing add 5, 8, you can just do add 5. And 5 will become the value for x, since that is the first parameter and the first argument. And because there is no second argument, y will use its default value 8. So if we run this code here, you'll see that 13 comes out. Similarly, you can do, of course, x equal 5 if you like, and still y doesn't have a value, so it will use the default value of 8. So this means exactly the same thing. What you can't do, though, is do this, y equal 5. Because x is a required parameter, you need to give it a value, and here we are not given it. So if we were to run this code, you would get that add is missing one required positional argument, x. So you need to give x a value. As usual, you can still do x equal 5, y equal 5, that's totally fine. And of course, you cannot do x equal 5, 5, because as we learned earlier on, you can't put a positional argument after a keyword or named argument. Similarly, that also applies for the add function definition. You cannot have a default parameter be followed by a non-default parameter. So here it'll tell you that a default value must be specified here in y because you've specified one earlier on. So default parameter values must go at the end after all the required non-default parameters. Something to take into consideration when you are defining functions is to usually not do this. So here we've got a variable called default underscore y, and it's equal to 3. And then we're defining an add function and making the y parameter equal to our default underscore y variable. So y will equal 3, and that will be the default value for the y parameter. Now we can call add with the value 2, let's say, and then it will do 2 for x and 3 for y, giving us a total of 5. However, if we then go and change default y to 4, and then we add again, let's say add 2, now you'll see that actually we get the same value back from the function. So changing a variable that has been used as a default parameter value does not modify the function. So this value here, this 3, is defined when the function gets created, and it doesn't change after that if you reassign the variable. So this is why I don't usually recommend doing this, because it can get really confusing really quickly. So stick to putting the actual value on the function unless you really have to do something different, and then make it clear that that value is not going to change after defining the function. So that is how you define default parameter values in Python. Just put them in the function definition. Just make sure they are at the end of the parameter list. Thank you for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about return values in functions. And this is something really confusing for new Python developers. Here we've got a function called add that prints x and y. If we call add with the values 5 and 8, it should print 13. So let's run that, and you'll see that 13 gets printed out. However, something that we have been doing with some other functions in our code has been assigning the value of it to a variable. For example, result equal add 5 and 8. If we then print result, you could potentially expect 13 to be printed out. However, here's what's going to happen. We're going to run line 5, which is going to start running the function, and it's going to print 13. Then we're going to run line 6, which is again going to run the function, because here, notice there is a function call, and that is going to run this line, which is going to print 13. Then we are going to assign something to the result variable. And finally, we're going to print the result variable. So we should see 13, 13, and then the value of the result variable printed out. So we're going to print out 3 lines. And you can see that we get 13, 13, and then none. None is a special value in Python that means no value, or missing value, or undeclared value. Take your pick. So that means that this function here, when it finished running, did something that made our result variable be equal to none. Because when we printed result, it printed none, therefore result must be none. So that is where return values come in. Functions return none. That's what they do by default. That means that whenever you call a function, you can assign its return value to a variable, or you can use it in another part of your program, such as a mathematical expression or something like that. And that return value is what you'll get when you call the function. So functions return none by default, which means that the result variable is being assigned to none. If we want to do it differently, you're going to have to return your own value. So we're going to say return x plus y without the brackets instead of print. Now, there's an important thing, which is that if we remove these lines, I'm just going to put the hash symbol in front of them, which signals that they are a comment, and they won't run when the code runs. If we press play now, you'll see that nothing gets printed out, because of course we've executed the add function, but this function does not print anything. It just returns something. So because we're not printing anything, nothing gets printed out. Now, if we do this, we call the add function, which returns the addition of the 2 arguments, 5 and 8, and then make it equal to the result variable. That means that result is going to be equal to the return value of the function, which is going to be 13, and then we're going to print 13. So when we run this code, you'll see 13. At this point, I'll say that very often I will see students doing this: print x and y, and then they will try to do this: print add 5 and 8. This is a very common thing I see in my courses, and notice that when you run this code, you're going to get 13 and then none. Again, that's because the add function gets called first, in order so that the print function knows what to print. So here it prints 13 and then returns none, because all functions return none by default. So you get 13 printed out, and then you get none printed out. And this is very common, so if you're seeing this problem or if you've encountered this before, now you know why that is. Let's go back to printing the result of calling the function, and we're going to make it both print and return. So now when we do this, you're going to see 13 printed out twice. One, because the function itself prints 13 out, and the second one because we're actually printing the return value of the function that we've assigned to our variable. Return not only gives a value back to the caller at the end of the function, it actually terminates the function entirely. So if we were to move this return value to before the print, and then press play, you'll see that only 113 gets printed out, because as soon as the function reaches this return statement, it returns and exits the function and gives the value back to the caller. So this print function never gets called. Only this one does. That is another common problem, that some people will put a return value elsewhere in the function, as well as the one at the end of the function. This is totally fine, you can do that, but just make sure that it is what you want, because when you return without a value, you're actually going to return none by default. So by putting a return here in line 2, it means that none of these lines are going to run because the function will terminate when you encounter a return, and this here will become none because there is a return with no value, which means return none. So result will be none, and you'll end up printing none out. If we press play, you'll see that none comes out. Let's go back to our divide function from the last video, but now instead of printing out, we're going to return. So here we've got a divide function with a dividend and a divisor. If the divisor is not 0, we're going to return the division, otherwise we're going to return the string you fool. So if we divide 15 by 3 and we print the result out, we should see a number coming out, and we do get 5.0. But if you decide to go for 15 and 0, and then you press play, you'll see that you fool gets printed out. This is fine. You can totally do 2 returns in a single function. As long as only one of them runs, which is what happens in this if statement, you can still access both returns depending on these conditions here. So again, a return will terminate the function when the line is ran and give the value returned back to the caller. So in this case, this function call here will be replaced essentially by whatever the function returns when it runs. As an aside, it's usually not recommended to have functions returning multiple different types of data. For example, this function can return a number or a string, just because if you wanted to perform mathematics on the return value of this function, you will encounter problems if you do return a string. For example, if you wanted to print out the result of dividing this multiplied by 5, then of course you're going to get you fool, you fool, you fool, you fool. However, if you change the number, then you'll actually get a valid mathematical number. So usually not recommended to return different types of data from a function, although, as I said, you can do it. It's just not advised. That's everything for this video. Thank you for joining me in this one, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about Lambda functions. A Lambda function is a different type of function which doesn't have a name and is only used to return values. Remember that we mentioned that functions can be used to perform actions such as printing something out, or operating with values and returning them, such as the sum function, or they can do both. But Lambda functions are exclusively used to operate on inputs and return outputs. They are almost never used to perform actions. Let's start with a simple function that gets some inputs and returns some outputs. Let's go to our trusty add function that returns x plus y. If you print add of 5 and 7, you've got that add 5 and 7 is going to run this line here, add x and y together, which gives you 12, and then it's going to return it, replacing essentially this entire function call by the value 12, and then we're going to print that out. So if we press play on this, you get 12. You can rewrite this function as a lambda function, which would be like this: lambda x comma y, x plus y. So what we've got here, and ignore this underline for a second, what we've got here is the lambda keyword, then we've got a space, and then we've got the list of parameters, which in this case are x and y. Then we've got a colon, and then we've got the return value of the function, but we don't specify the return keyword. So lambda functions are used to return outputs. You don't need to specify return because that's what they're for. So Python will infer that. So this does exactly the same thing as the add function earlier, but it doesn't have a name. Notice that the add variable is never created. So to solve that problem, if you want your lambda functions to have a name, which sometimes you won't, and I'll show you why not in a moment, you can just assign that to a variable. So here we've got the add variable, make it equal to our lambda function, and then you can call it in your program using add. So again, there are 4 parts to a lambda function. You've got the lambda keyword, then you've got your parameter list, then you've got your colon, and finally your return value without the return keyword. Lambdas are meant to be short functions, often used without giving them a name. For example, in conjunction with the built-in function called map. So we're going to learn about map in a moment. However, you can give them a name if you want. If you didn't want to give it a name, then you would have to use it in the same line where you define it. Otherwise, as soon as you define this function, you have no way of actually using it because it doesn't have a name, so it's kind of pointless to just define the Lambda function without using it. If you wanted to use this Lambda function, you need to surround it in brackets so that Python will treat this as a single unit, and then call the function here, say with the values 5 and 7, and this here means that you're using the 5 and 7 call on this thing, which is a Lambda function, which essentially calls the function with the arguments 5 and 7. You can see why this is also not very often done, because it's extremely confusing, and this will still not do anything, because you still need your print function around it as well. So Lambda functions used in this way, not very common at all. Usually you will define a proper function and use it like we did earlier on instead. But let's get into some uses for Lambda functions that are actually useful. Let's say you've got a function called double that doubles a number passed into it, and then you've got a sequence of numbers such as 1, 3, 5, and 9. And you want to double this sequence, or you want to double each number in this sequence. Something that you may see is something like doubled equal, and then use a list comprehension, x times 2 for x in sequence. So x times 2 is the same as this function returns for its given inputs. So instead we can do double x for x in sequence. The benefit of this is that using a function call allows you to potentially perform larger or more complicated mathematical expressions without making your list comprehension more complicated. At this specific point in time, it's not a big difference, but it can be in other scenarios. So instead of doing this list comprehension, you can use the map function, and that is where Lambda functions become extremely useful. So instead of using that, you can do doubled equal map of double on sequence. And that does exactly the same as this list comprehension. What map does is it goes over each value in the sequence, such as a list, a tuple, a set, and so on, and it applies the double function on each element, and then returns the final sequence out to you. So that's what map is for. It's very useful. So it is the counterpart for this list comprehension here. In Python, you would usually use list comprehensions, but many other programming languages don't have list comprehensions, so they have to use things like map. So if you are working with developers familiar with other programming languages and you want to use a programming style that they will be familiar with, you can use something like map. In addition, if you're working in a large project and you are using multiple different programming languages such as JavaScript as well as Python, you may want to use map so that your Python code and your JavaScript code both have similar style. With that said, though, the list comprehension is usually slightly faster, so there is no reason to use things like map over list comprehensions most of the time in Python. Let's rewrite this example using a Lambda function. Your doubled list comprehension here could define a Lambda function here, Lambda x times 2, and then use x as the argument to that function, and then you no longer need this doubled there. But this is getting quite confusing because, as I mentioned earlier on, you have your Lambda function which must be surrounded by brackets, and then you have another pair of brackets to pass in the argument, so this is a little bit unreadable. So if you want to use Lambda functions, you should use map instead, just because it makes it a little bit clearer without so many brackets what's going on. By the way, if you want to run this code and check the value returned by map, you need to turn it into a list in order to be able to print it out, just because the map function doesn't return a list of numbers, it will return something called a map object. We're going to learn more about what those things are as we move through these videos, but for now just turn it into a list if you want to see the values in your console. So just to recap, lambdas are functions without a name. You can give them a name by assigning them to a variable, but they don't have a name in the function definition. They are used to return a value calculated from its parameters, and they're almost never used to perform actions. They're almost always single line, so you don't want to be doing anything really complicated in them. And one of the big reasons why they're single line is because their syntax gets really complicated to read as they get longer. very often it's better to define a normal function than a lambda function in most situations. Lambda functions, I personally don't use them very much because I find them that they are a bit difficult to read and keep track of, especially as your programs grow. And that's it for this video. Thanks for joining me, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about dictionary comprehensions. A dictionary comprehension is very much like a list comprehension, but we get a dictionary at the end of it, so we need to be assigning key value pairs instead of only values. Let's say we've got a list of users, where each user information is stored in a tuple. So we have a list with 4 user tuples inside it. They have an ID, a unique identifying number for each user, a username, and a password. So we want to create a mapping of usernames to user information. This is something that you'll be doing very often, especially if you're doing something like web applications and things like that. So we can do a username underscore mapping variable. Remember, this name here doesn't matter. You can pick whatever you want. And then we're going to do a dictionary comprehension. So we'll do user1:user. This is our key and our value for user in users. And that is our for loop. So in a dictionary comprehension, the value that you're going to put into your new dictionary is actually a key value pair. And then you've got your for loop just as you had in your list comprehensions. What this ends up doing is getting the user name and associating with it the entire user tuple for each of your users. So if we print username mapping out, you'll see what I mean. You end up with a rather long dictionary where the keys are the usernames and the values are the entire tuple, the whole piece of information that we have about a user. Why can this be helpful? Well, imagine you know a user's username and you want to get their information out. You just access, let's say, Bob in your username mapping, and you've got the information out. So here you would get back the entire of Bob's tuple. If you didn't have a mapping, you would have to do something like this. For user in users, then you would have to check if user1 is equal to Bob, and then you would print user out. So as you can see, this is rather complicated in comparison, once you know what this means, of course. Let's say that you've got something like this in your application and you want users to log in. What you would do is you would ask the user for their username, and then you would ask them for their password. So you can do password input. Now that you've got the username and password, all you have to do is go into the mapping and get the user for their username. So we can say something like username password equal username mapping username input. And this is going to get the user information tuple, such as this one, and it's going to unpack it or destructure it into these 3 variables. The underscore variable, because we don't care about the ID, the username variable that will be Bob, and the password variable that will be password. Then, if the password input is equal to the password that we found in our sort of database, quote unquote, on our list, then we can say that your details are correct. And otherwise, we can say something else. So this is an example of performing some sort of login using this structure here, this dictionary comprehension. This is really helpful because it saves you from having to do another for loop here to make sure that you are using the right username for their input. I just wanted to show you how dictionary comprehensions work in Python, and I thought that an example like this one could be quite nice as well. So now that we know about dictionary comprehensions, we're ready to move on to the next video. I'll see you there. Hi guys, and welcome back. In this video, we're going to learn about unpacking arguments. And this is a little bit more complicated than what we've seen so far, so please do bear with me. I'm going to define a multiply function that takes in any number of arguments. Here's how. We create the multiply function as normal, and in here, we're going to put star args. Now, the star is the important part. The args is just a variable name that will be used to collect the arguments. So let's print the args out. And for now, it's not going to multiply anything, it's just going to print them out. So what's happening here is we've defined a function and we've said that the function has a set of arguments that will be collected into a tuple of arguments when the function gets called. So if we do multiply and then we do 1, 3, and 5, notice that here I'm passing 3 different arguments, but this only has seemingly a single parameter. So I'm passing 3 different arguments, and what's going to happen is they are going to be collected into this args variable. So I'm going to save this and run it. And you can see that what we get printed out when we run the function is a tuple of my arguments. So we've got 1, 3, and 5 printed out as a tuple. If we wanted to multiply all these numbers together, we can just iterate over the arguments. So for arg in args, we can say total equal total times arg, and then return total. Then we can sort of print that out. Now what we're doing here is we're starting off with a variable which is 1, and then we're multiplying that variable by each of the arguments, and then we're returning the final value. If we run that, we get an error because we left the S there, so let's run that again. There we go, we get 15 printed out. So this is a way of collecting multiple arguments into a single variable when you are calling a function. And this has a number of uses that you will definitely be seeing quite a lot as you program in Python. Notice that you can call this function with 1 argument if you want, and that's totally fine as well. It just creates a tuple of a single element. Let's go into another example. Let's say we have an add function with 2 parameters, x and y, and then you have a list of numbers, 3 and 5. So just as we can use the asterisk to collect arguments into 1 parameter, we can go the other way around and we can use the asterisk to destructure arguments into multiple parameters. So you can do add star nums, and what this will do is it will use 3 for x and 5 for y. So it is destructuring the nums variable and splitting it out into multiple values such that one value can go to 1 parameter. Notice that if you do just nums here, you're going to pass 3 and 5, the list itself, as the value for x, and y is not going to have a value, so you're going to get an error. So by doing this, it passes 1 value for each parameter. Of course, you do need to have the same number of values in this list as parameters in this function. Otherwise, you're going to have an error where you're going to have too many parameters or too many arguments. Let's print this out so you can check that it works. There you have it. 8 comes out. Now, this can also work with named arguments. So remember, you can call the add function by doing x equals 3 and y equals 5. So you can do something like that using these asterisks. Let's say that you've got your nums, and these are now a dictionary with a value for x and a value for y. If you wanted to use this dictionary as the arguments to these functions, you would have to do nums x and nums y like that, which is kind of ugly and also difficult to read. You're starting to get a lot of brackets and square brackets and so on. If you wanted to be even more specific, you can do x equal nums x and y equal nums y. And here is where the magic happens. You can see that the parameter name is the same as the key in the dictionary that we are using as a value for that parameter. So x is the key x and y is the key y. Instead of doing this entire thing, we can tell Python to pass in this dictionary as named arguments, where the argument will be equal to the value associated with that same name for a key. So essentially doing exactly this, but just do star star nums. And that will do the same thing. So because we're using star star, it'll say, okay, you've got a dictionary with 2 keys. What I'm going to do is I'm going to pass in each key as a named argument, and the value is going to be that associated with the key. So it'll say x equal nums x and y equal nums y. I know that's quite a complicated thing, but it simplifies your code so much when you can use dictionaries like that. Let's go back to our multiply function that we had earlier on with this collected set of arguments. And I'm going to create another function called apply. And now we're going to say star args, comma, operator. So this is a special bit of syntax in Python, and what it means is collect all the positional arguments into this tuple args, and also have a named argument at the end. This creates a compulsory or required named argument. So when you're calling this function, you're going to pass in as many arguments as you want, and they will all be collected into args, and at the end, you must pass in a named argument for this one. So let me just give it a body there, and we're going to say if the operator is equal to the asterisk, we're going to return multiply of args. Otherwise, if the operator is equal to plus, we're going to return the sum of args. And finally, we're going to return no valid operator if it's neither of them. Now, I have a bug in this function, and you may notice what it is based on what we've seen already, but I know that you don't have a lot of practice with this yet, so it is possible to not notice it. That's fine. We're going to print apply of 1, 3, 6, and 7, and the operator is going to be plus. So this is how this function must be called. You can pass in as many arguments as you want. They will be collected by args. Finally, you must pass in a named argument for this one there. If you just pass in plus, Python's going to try to collect it with args, so you're going to miss this parameter. Indeed, if we run this, you'll see that you get an error, missing one required keyword-only argument. So you do need the operator in there. So if we run this, it'll all work. You get 17 back because that's the addition of all of these numbers. However, if you change this to a asterisk, then you get back a tuple. So why this tuple? Why not the multiplication of all the numbers? Is there a bug in our multiply function? Well, you might be tempted to go through and see what the multiply function is doing. Multiply function starts with a variable called total that has the value of 1, and then it goes through the arguments and makes total equal to total multiplied by the arg. So how on earth is it managing to end up with a tuple being returned? Well, if you multiply 1 by a tuple, you actually end up with that tuple. So that means that args must be a tuple of tuples, such that the first argument, the first arg in the tuple, is itself a tuple, such that you're multiplying the tuple by 1 and ending up with the tuple itself and then returning that. So the best way to do this is to use a debugger, but we haven't learned how to use a debugger yet. So we're going to print the arguments, and you'll see that you're going to get something a little bit weird. When you print the args, you get a tuple of tuples. And then when you iterate over the args, arg is the inner tuple. You're multiplying that by 1, making it equal to total, such that total is the tuple. And then because that's the only value in args, that is the end of the for loop, and you return the tuple. The reason for that is because we did not pass in individual arguments to the multiply function, we passed in a tuple. We want to put a star here. The reason for that is because when we call the apply function, we're passing in 4 different arguments that are being collected into one tuple by the star. But when we call the multiply function, we want to pass in 4 different arguments so that they can be collected by args inside the multiply function and then used in here. But before, we were passing the args tuple itself, the collected tuple in this function. What we want to do is we want to unpack it into 4 values and pass them as individual values to this function so that they can be recollected by args here. The other option is to remove the star so that you are passing a tuple directly to the multiply function, and then removing this star so that the multiply function won't try to collect all its positional arguments into another tuple. However, I do like passing multiple different arguments, so I'm going to keep the stars there, but that's a choice for you to make. You can either pass arguments or you can pass a tuple. That is a very common problem and quite a difficult to diagnose problem as well. So I just wanted to go through it so that if you encounter that in the future, you'll know what's going on. Thanks for joining me in this video. I hope it's been useful and not too confusing, and I'll see you in the next one. Hi guys and welcome back. In this video we're going to learn about unpacking keyword arguments. The last video was a little bit confusing. Now it's going to get a little bit more confusing as we learn about keyword arguments. Once these two videos are over though, you're going to have all of the tools necessary in Python to create any type of function and use it in many different ways. So up to now, we've been learning about all these fundamental building blocks, and this is one of the last ones. After this, we can learn about object-oriented programming, and that's another type of beast altogether. Let's start by defining a simple function that will use this unpacking of keyword arguments. So I'm going to do ** quargs. Now, args and quargs, when you use *args and ** quargs, are the usual names for these things, but they don't have to be. You can use whatever variable name you want here, and indeed with *args as well. We're going to just print them out, so I want you to take a look at what happens when I call my named function and I say something like name equal Bob and age equal 25. If I run this code here, you can see that what we get out is a dictionary. So we called our named function that does this dictionary unpacking with two keyword arguments. And what happens in Python is that these keyword arguments all get collected into this quargs variable. That is what the ** does. It collects keyword arguments. So all of these keyword arguments get collected and put into a dictionary where the dictionary key is equal to the name of the keyword argument. So you end up with a name key and a Bob value for this one, and an age key and a 25 value for this one. The same way that you can collect named arguments into a dictionary, you can go the other way around. You can unpack a dictionary into named arguments. So I'm going to make a small change to my named function. I'm going to pass in name and age, and I'm going to print them out, name and age. And now I'm going to define a details dictionary which has a name of Bob and an age of 25. Now I'm going to call my named function with my details. We know that this won't work because details is a dictionary and I'm passing it as a positional argument, which means that the details dictionary will become a value for the name parameter, but the age parameter will not have a value. We need to pass that in separately, something like this. But of course, that's not what we want to do. We don't want to pass in this whole thing as a name. That would be a bit weird. And if you run this, you'll see that you get the entire dictionary printed out because that's the name variable, and then 25 printed out because that's the age variable. Instead, what we want to do is we want to pass in the name key as the name parameter and the age key as the age parameter. And we saw how to do this in the last video just by unpacking the dictionary into two named arguments like that. When you do that, it treats the key as the name for the argument and age as the key for the argument and assigns to them the value associated with those. So you do end up now with Bob and 25. Note that if you had ** quargs, which is the collection of multiple named arguments, you can print them out and you can still do this. What will happen now is instead of doing name equal Bob and age equal 25, you're doing exactly the same thing, but using this dictionary to pass in multiple keyword arguments, and then they are being collected into this dictionary up here, and then you're going to print the dictionary out. So that is how these two stars work. They can be used in a function to collect named arguments into a dictionary, or they can be used in a function call to unpack a dictionary into keyword arguments. Let's say we have another function called print nicely that is going to print out this dictionary into a nice format. So let's call the named function first to print the arguments out, and then we are going to print them nicely. So we're going to do for arg and value in quargs.items, then we're going to print arg and the value. Notice that quargs is a dictionary, so you can use the items method on it so that you can iterate over two of these things. Notice that here we're using a whole bunch of things that we've learned so far, including normal data types like dictionaries. We are calling functions, we are destructuring the tuple that returns into two values, we are even unpacking and repacking named arguments. So there's a lot of stuff going on here, and I know it's a little bit confusing. Now with this function, we can do print nicely, and we can pass name is Bob and age is 25, and what's going to happen is we're going to collect these named arguments into this dictionary. Then we're going to call the named function, but we're going to unpack that dictionary into named arguments. So we're going to pass in name equal Bob and age equal 25. Those are then going to be collected into this dictionary, and they're going to be printed out. So we're going to print a dictionary. And then we're going to come back out here and we're going to iterate over the items, getting arg and value for each item in the dictionary, which is going to give us name and Bob, and then age and 25. And finally, we're going to print those out in a bit of a nicer way. So we're going to print the dictionary first and then 2 more lines. And that is indeed what we get back. You can use both, actually, star args and star quargs if you want. And nothing changes. You're going to collect all the positional arguments into args and all the named arguments into quargs. So you can do something like both. 135, name equal Bob, and age equal 25. 1, 3, and 5 will be collected into args because they are positional arguments. Name equal Bob and age equal 25 will be collected into quargs. So if we run that, you can see that you get a tuple of arguments and then a dictionary of arguments. This syntax here, args and quargs with the stars, is normally used to accept an unlimited number of arguments. So you can pass in anything you want to this function, any positional arguments and any named arguments, and it will accept them. And that is normally used so that some of those arguments or all of those arguments can be passed on to another function. Here's an example of something that is done quite frequently, and we haven't written this code, don't worry about how it's implemented, but you have a post function that takes in a URL, some data, some variable called JSON, and then any number of keyword arguments. And it returns just calling another function, and it passes the URL, the data, the JSON, and all of the keyword arguments. So it essentially seems to do the same thing, but it also adds an extra argument. So this is a very common pattern to do in Python, to have a function that seemingly just calls another, but adds something more to it. And that is used to simplify calling this initial function so that you don't have to pass in this argument as well. So just an example of the quargs being used to essentially pass arguments from one function to another until they get used. So that's a very common thing to do. A final example, if you define a function that uses this unpacking, you need to call it with a mapping if you're going to pass in this star. So if you do star Bob, you're going to get an error because this is not a dictionary. Similarly with star none, you're going to get an error because that's not a dictionary. So if you're working with variables in your code and then eventually you're passing them unpacked to a function, then you must make sure that they are dictionaries. If they are anything else, then you're going to get an error when this line runs. So that's something that you'll see quite frequently in Python code. The variable has an unexpected value or something like that, and students sometimes struggle to determine why you get an error. That's because sometimes the variables that we use may not be what we expect. That's it for this video though. Thanks for joining me in this one. I hope you've enjoyed it, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about object-oriented programming. Object-oriented programming is a bit confusing when you get started. So if you've never seen object-oriented programming before, just take it easy with the next few videos. Watch them a couple of times if you need to. Ask any questions in the course or Q&A if necessary. We'll be there to help you out. Object-oriented programming allows us as developers to write code in a slightly different way than we would write if we didn't have object-oriented programming. The purpose of object-oriented programming is to make our life as developers simpler by allowing us to write code that looks like what we would work with in the real world if we were talking about, real world things like chairs and tables and printers and things like that, as opposed to code and data passing from one function to another. So that is the purpose of object-oriented programming. And in this video, we're going to look at how it works in Python. Let's say that you've got a dictionary like this one here, which shows some information about a student. Now, Clearly, this thing here is not a student. It is a dictionary that has some data. And as we know, programming is all about data and passing data from one place to another and so forth. So what we've got here is some data that is probably about a student somewhere in our classroom or something like that. Then we've got a function that takes in a sequence and adds the entire sequence together and divides it by the length of the sequence and then returns that, so it gives you the average of a sequence. For example, we could use it to calculate the average grade of Rolf. How would you do that? Well, you would have to use the function and give to it Rolf's grades. So you do average student grades, like that. So if we run that, you'll see that we get out the value 88.0, which is the average grade. However, there is something about this function which is very important when you are thinking about object-oriented programming, which is that this function doesn't know anything about the student. The function only operates on the input that it receives, and that could be a set of student grades or it could be something else. So when we as developers are talking specifically about a student and we want to calculate specifically the average student grade for Rolf, it is much nicer if we can say, hey student, what's your average? As opposed to get the average of this sequence that could or could not be related to the student. So basically what I want to do is student.average. This is what object-oriented programming will allow us to do. But in order to do that, student cannot be a dictionary, because dictionaries you can't do that on. You have to code your own thing in Python that will allow you to call the average method inside it, and that will give you the average of the student. So it is a very different approach, and it is not necessarily superior, but it is different and it allows you to think of your programs in a different way. So let's rewrite this example here using object-oriented programming so you'll have a look at the syntax. The syntax for object-oriented programming, or to define a class in Python, is to type out the keyword class and then the name of your class. So a class is a definition of something, but it doesn't create a particular student. Here we're only defining how a student would behave. So you can say inside the function, notice that there are 4 spaces of indentation. You can define functions. So you can define a special function called the __init__. So this function name is very important, and it has 2 underscores at the start and 2 at the end, and then you put your brackets, and in here we're going to type out self. Although this is again just a variable name like in every other function, and you can call it whatever you want. It doesn't have to be self if you don't want, but self is the convention in Python. Then in the body of the function, you can define anything you want. For example, self.name is going to be Rolf. And what this is doing is it is taking whatever self is, and it is accessing the name property inside of self. So here we're using the dot notation to access something inside of self, and what we're accessing is the name property, and then we're giving it a value of Rolf. What that means is that when we use this class to create something, that thing is going to have a name of Rolf. So here's how you create a thing from a class. We can say something like student. Notice that now this is lowercase because this is a new variable that we're creating right now, is a student, which is uppercase S because this is the class. And now we're going to tell it to use the class to create what's called an object in Python, to create a new thing that behaves like what this class defines. So when you do this, Python creates a new, essentially empty container, if you will, and it runs the init method. And by the way, it is a method and not a function because it is inside of a class. So when a function is inside of a class, it's called a method. So when you call the student class, notice that this bracket notation here is used to call a function normally, but we can also use it to call a class. When you call that, Python will automatically call the init method for you, and it will create this empty thing called self, and you will be able to modify the name property inside self and give it the value Rolf. The name property won't exist by default, so doing this also creates it, which is quite nice. So once that's done and this self object contains a name property, Python will give you back that self, and student will become a name for the self thing we created, that thing being an object. That's what they're called. So we're using this class through the init method to create an object and assign the name property inside that object to the string Rolf. Then that object is what becomes the value for our student variable. So you can now do print student.name. And here what we're doing is we're accessing the name property of our student variable, which, as you know, is the self that we created earlier on. So that will give you Rolf. And if I run that, you'll see that Rolf comes out. This is how object-oriented programming works in Python. You call a class, the init method runs, and what you get back is the object you created, and in the init method you have the opportunity to set and change its properties. So what we've got here is the name property that we're changing. As well as self.name equal Rolf, we can do self.grades and make it equal to what we had before. Something like that. So we're making the grades property of self equal to this tuple. And then when the function finishes, the class gives back self to student, and now you can print out student.grades if you want, and that property will exist there as well, as you can see. So nothing terribly complicated up till now. There's a bit of data being passed from one place to another, but this is no different to what we had before, really. If you wanted to get the average of these grades, you would still have to, pass them to a function called average, for example, and that would give you the average if you have the function defined. But using object-oriented programming, there's one more thing you can do which is going to simplify your life greatly, and that is the main point of object-oriented programming, which is to define another method, such as the average method inside the class. And this method will take self as a parameter. Notice that self, again, doesn't have to be self. You can call it whatever you want. That's just the convention in Python. We usually call it self, but you can call it whatever you want. So if you define a method inside a class, all the methods inside the class have to take a parameter, which will be the object that was created initially. You can do return sum of self.grades divided by len of self.grades. Notice how this method here does not take a sequence. It just uses the object that was created up here. So how does Python know that it is to call this method with this data here? Well, here's how it works internally. When you create a new class, the init method runs, and you get this new object placed in student. Then, whenever you want to call this method here, all you have to do is type out student, the class, dot average, and then of course, because this is just essentially another function, you put in there the student object. And what this is doing is it's calling the average method inside, that's what the dot means, inside the student class, so that's this one there, and the self parameter is going to take the value of the student variable, which has that object that was created earlier on that contains a name and a grades. So if we save that and run it, you can see that you get 88.2. Now, this is a little bit verbose. There's a few too many words in there, so Python has a nice bit of syntax that you can use instead of this one, which is to remove the student argument from the average function, and instead of calling the average method inside the class, call it on the object itself. So if you do student.average, Python is going to realize that, okay, student is a student object, so you probably want to pass it as self, as the first argument. So it will do the conversion for you. That is the same thing, one as the other, but this is a little bit shorter, a little bit easier to read. And if you name your variables well, then this is pretty obvious what it's going to give you back. It's going to give you the average of this student. Now you can make it even better, type average grade, say, and that's going to be just a little bit more readable as well. And just to show you that this works, it does exactly the same thing. So this is the key benefit of object-oriented programming. You can define methods inside a class that use the object that was initially created by the init method within them, so that you don't have to keep track of multiple different pieces of data, and the object itself can contain these methods that you want to use inside it. So all the data and the methods are in one place inside the class. Now the init method can also take arguments or have parameters. For example, we can have a name parameter as well as self. So just to recap, all methods inside a class need to have a parameter such as self so that they can take in the object that you have been constructing. But they can also take more arguments. So here we're going to have another parameter, the name parameter, and then you'll put the value of that parameter in the brackets of the student class call. So we can put here Bob, let's say. So now Bob will become the value for name. Notice that self is given for you, so you don't have to give it a name. This here will become the value for name. But notice that we're not using this name parameter anywhere. We are accessing here self.name, but that's the name property inside self. It is not this parameter. If you wanted to access this parameter, you can do that by doing something like that. Self.name, which is the name property inside self, will take the value of the name variable inside this method, which is this parameter here. So now if you print student.name, you'll see that Bob will come out, because that is what we defined in the init method. Let's do the same with grades. And now, as well as name, we have to pass in a set of grades for the student. For example, we will do this one, give it just a little bit of a different set of grades there, and now we can press play and notice how the average grade changes. The average grade is now being calculated from this set of grades because they are stored in self.grades for this student. So when the average grade method is called, it uses those grades. Remember that you can define multiple students if you want, and that's totally fine. This call here in line 10 will call the init method. It will give you a new object. It will populate self.name of that object with the name argument and self.grades of the self object with this argument, and it will give you this student variable back. I'm going to call this student2. The student2 variable, exactly the same thing, calls the init method, passes Rolf as the name, and it creates a new object and sets the name property of that new object to Rolf and the grades property of that new object to this set of grades here. And what you end up with are two separate containers of data. The student variable, which is Bob and has these grades, and the student2 variable, which is Rolf and has these grades. So when you call student2.averageGrade, again, what Python is doing is it's calling the student class and passing student2 there. So self is student2. When you sum the grades, you're going to be summing these grades here because those are the grades that are stored inside student2. But of course, you can still do student2.averageGrade instead, as that is a bit simpler. Pressing play now will give you 92.2 and 88.2 as the two averages, one for each student. Alright, that's everything for this video. I wanted to tell you a little bit about how object-oriented programming works in Python, how you can define classes, how objects are created, and how methods work so that you can call them with the data in those objects. I hope it's all clear, but if it isn't, please ask a question in the course Q&A. We'll be more than happy to help you out. Thanks for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about two methods, the str and the repr methods. In Python, methods with 2 underscores on each side are special methods, also called magic methods at times, because Python will call them for you in some situations. For example, when you do person, Python calls the init method for you, even though you didn't say python.__init, So that is why it is a magic method. You don't have to call it yourself. Python can do it for you at times. So let's create a person that I'm going to call Bob here, and he's going to be 35. Here we're creating a person object by calling the class. Then Python calls the __init__ method, gives us a new empty object that we're calling self, and then we're setting the name and the age properties of that object to be our parameters. That are arguments here. So Bob and 35 will be stored in Bob's name and age. Now, if we print Bob, then you may see something a little bit weird, which is this. That's less than __main__ dot person object at a bunch of numbers. Greater than. So what does this mean? What Python is doing at this point is when you've told it to print Bob, Python is going to print out a string representing the Bob object that we've created. And the reason why Python is printing out a representation of the object is because you can't really print an object. You have to print a string, some characters and numbers and so on. So Python is saying that this string that it printed out is what it thinks represents our object. This is a default string, and all objects and all classes you create will look something like that unless you change it yourself. So the purpose of printing out an object can be twofold. The first purpose can be to return a nice, easy-to-read string so that in your applications you can print out an object and your users can make use of that. For example, if they wanted to know about this Bob person, then potentially you could print out Bob and it could show them some nice information about Bob. The other reason to print out an object can be for programmers. You can print out an object so that you can see the object's information in case you want to recreate the object. Let's start off with the first option. We're going to modify Bob so that when we print him out, we'll get some nice information that our users can make use of. The way we do that is we do def__str__. Then, of course, the self parameter, and in we go to the body. The __str__ is a method that is a magic method because it has the 2 underscores on each side, and this method gets called for you when you want to turn your object into a string. Let me just return hello from here, and now we're going to print Bob. Notice that we get hello out. Because what Python has done is when you ask it to print an object, Python realizes that really what you want is a string representation of that object, since that's the only thing you can actually print out in a console. When you ask it to print an object, it is going to turn that object into a string using the str method, and then it's going to print that. So instead of returning hello here, we could return something a bit nicer. Remember, the goal when you're using the __str__ method is to print out a nice, easy-to-read string for users. So we're going to print something like this: person self.name, self.age, years old. Now, if we run this code again, you'll see that we get person Bob, 35 years old. You can remove the person if you like. So as well as the str method, you have another one called the repr method. The goal of the repr method is to be unambiguous, and if possible, it should return a string that allows us to recreate the original object very easily. So I'm going to return person self.name self.age, like that. Notice that I'm putting less than and greater than symbols. That is just for looks. It is to tell programmers that read this string here that we are printing out an object. Now, if we press play, you can see that the str method's output is still printed out. That is because by default, when you print out an object, Python assumes that you want to show it to your users. You don't want to show the output of the wrapper method, you want to show the output of the str method. The wrapper method is used in a few other places, such as the Python debugger that we will learn about later on, but usually the str method is used. So if you want to make sure to test out your wrapper method, just comment this one out, put a couple of hash symbols in front of it, and then press play, and then you see that you get person Bob 35. And if you really wanted to, you can put the quotes in there so that when you press play, you get a string back. That's even better. So we've learned about two methods that you can implement in your classes, the str and the wrapper methods. The str method is called when you want to turn your object into a string, such as when printing it out or even when doing str of Bob, as we have learned previously with integers. The wrapper method is used to print out an unambiguous representation of an object so that you can use that to recreate the object, for example, if you were a programmer looking at that output. Usually you'll want to implement the str method, but implementing the wrapper method can also be quite nice. And remember, you don't have to use these two. They're only used for representing an object as a string, but you don't have to do that if you don't want. That's it for this video. Thank you for joining me, and I'll see you. Hi guys, and welcome back. In this video, we're going to talk about static methods and class methods. These can be a little bit confusing, so let's get started. Here we've got a class that I have called class test. This is just to show you how these things work. And then we have defined a method. We know it's a method because it is a function which starts with a def keyword and it has self as a first parameter. All functions inside a class that use the object as the first parameter are called instance methods. And this instance method prints that you've called the instance method. So how would you call this method if you wanted to call it? You have two options. Okay, the first option is to do something like test equal class test and create a new object of type class test. Notice that we don't have an init method in this class, but that's okay. If you don't have an init method, that just means that you don't have any initialization to do, but the self is still created and you still get a new object and make it equal to your variable. So here we're creating a new object, and you can do test.instance method, or as we know, you can do class test.instance method with test as the argument. So both of these things are exactly the same. If you run this code, you'll get that you've called the instance method of this object. Notice that we are printing the object self here, and as we saw earlier on, you get back this ugly printout. If you wanted it to be a little bit nicer, you would have to implement your str or wrapper methods, one of the two. But for now, we have called the instance method two times. It is called an instance method because you call it on a class instance. The name instance means the same thing as an object. So what we're doing here is we're creating an object of type class test, and you can also say that you're creating an instance of class test. They mean the same thing. So that is why these are called instance methods. So instance methods need the object in order to call them. The next type is called a class method. Here you can define another method, but now instead of the instance or the object self, it actually takes a different parameter that we usually in Python call CLS, but you can call this parameter whatever you want. The value will still be the same no matter what you call this parameter. And what this parameter will be in a class method, that is when you put this @class method on top of the method definition, is this will be the class itself. So let me show you how this works. Called class method of CLS. I'll just print the parameter there. And then, because it is a class method, it's not an instance method, you no longer need an instance. That means that you can just do class test.class method, and that's it. You don't have to pass in anything in there because we no longer need the object. Python is smart enough that when you do class test.class method and you don't pass anything in there, Python will actually pass class test in there. So actually CLS is class test, because that is what you called the method on. So that is how this works. When you do class test.class method, given that you have put this at class method on top, we're going to learn what this is later on, don't worry about it too much, then Python will pass in the class as the argument to this parameter. So if we save and play, you'll see that now you get that you've called the class method of this class called the class test. Don't worry too much about the __ main __. We will learn about that later on if it becomes relevant. It's largely irrelevant to most Python programs. This just means that you've called the class method of this class. We're going to find use cases for class methods in just a little bit later on in this video. Finally, the last option is the @static method. And this defines a static method that I'm going to call static method. Again, you can call it whatever you want. And now I'm not going to put anything inside the brackets. So here we're going to do call static method. In a static method, that is a method that doesn't have a parameter CLS or self, and that has @static method on top, these methods don't get anything when you call them. So the class method gets the class normally, and you can print it out or use it. The instance method gets the instance or the object, and you can print it out or use it in them. But static methods don't get either of those things. And you can call them in the same way just by doing static method inside class test, so class test.static method, but Python will not put the class test in the brackets, it will just call that method. This really isn't a method, it's just a function that you've placed inside a class. We should still call it a method, but it doesn't have any information about the class or the object, so it's really just its own separate function that lives inside the class. So if you want a function inside a class that doesn't use the class for anything or the instance, you can decorate it with @static method. If you want a method that uses the class for something, then you can decorate it with @class method. And if you want to use the object, or if you want to create any other type of instance method, then just don't put anything on top, no @class method or @static method, and make sure to include your parameter there. Again, if you call this like that and you press play, you just get called static method. So what are these used for? Instance methods are used for most things. When you want to produce an action that uses the data inside the object that you created earlier on, for example, that is when instance methods would get used. Also, if you want to call a method to modify some sort of data inside self or the object, then you would also use an instance method. Class methods are used often as factories, and I'm going to show you what that is in a second. And finally, static methods are used to just place a method inside a class because you feel like it belongs there for some reason. For you as a developer, you want to put that method in there because it makes sense logically for like code organization or something like that, then you can use that. I'll say though that most of the time you'll be using class methods and instance methods. You won't be using static methods all that much. Let's start with our factory example that is going to show you how you might use a class method. This example is going to be a little bit tricky, so please bear with me for a second while I explain first what I've done here. In a class, as well as methods, you can also put variables, and these become class properties. So if you wanted to print out this tuple here, all you have to do is access the types tuple inside the book class. So you would do book.types. And that is how you access this tuple there. You can print it out, and you can see that you get hardcover and paperback. Okay, so we have some data stored inside the class, which is this tuple here. And a reason why you might put some data inside a class, as opposed to putting it outside the class, is because you feel like it belongs there, or only the book class is going to use it, or maybe there is some sort of reason, logical reason to put that data in there. Here I'm creating a class that talks about books, so it makes sense to have book types inside there. Then we're going to create an init method for this class. Remember, because this is an instance method, it creates an instance and gives it back to you. You need the self parameter there. You can call self whatever you want, once again, but the convention in Python is to call it self. And then we're going to be creating objects of type book that have three things: a name, a book type, and a weight. So we will do self.name equal name, self.booktype equal book type, and self.weight equal weight. This is a very common thing in Python to create an object with 3 different values that you then store each one inside a property of the object itself. So just to recap, if you were to create a variable such as book and make it an object, then you would need to pass in some information. Let's say Harry Potter, hardcover, and 1500. Then you can print book.name. And what that's going to do is it's going to pass in Harry Potter as the value for this parameter. Then that is going to be assigned to the name property of the self object, which is essentially an empty container at this stage. And then we're going to print it out down here. So if we press play, you'll see that Harry Potter comes out. So that's how the data is flowing through this system at this stage. Then I'm also going to create a repr method so that it's a little bit easier to work with these books. And we are going to return a book with this name. It is this book type, and it's weighing self.weight grams. Okay, so this is a representation of the book that would allow us, with all the data included inside, to recreate a book object if we wanted to. Remember, that is the purpose of the repr method. If you wanted to just print the book out nicely for users to read, then you could use the str method instead. So now, instead of printing book name, we're just going to print book, and I will press play and show you what the output is. Here's the book Harry Potter, which is a hardcover weighing 1500 grams. Now we come into the factories. So here's where we're going to use class methods. I want to avoid, when I'm creating a new book object, when I'm calling the init method, I want to avoid passing in this hardcover string, because I only want to be able to create books that are either hardcover or paperback. I want to make sure that when I create a book, I use one of these 2 types. Right now, I can pass in comic book if I wanted to here, and that would be totally fine, because again, the data, this string here, becomes the value of book type. Book type gets assigned to self.booktype, and that gets used down here. There is no check for this. Nothing is using this at the moment. So what I'm going to do is I'm going to create a method that will take in the name and the weight and will create a new book object of type hardcover. So I'm going to call this class method hardcover. And again, because it is a class method, it takes in the class as the first parameter. You usually call that CLS in Python. And then it's going to take in the name and the page weight. And what it's going to do is it is going to return a book with the name as the first argument, which then goes into the init method, book.types 0 as the second argument. Remember, book.types gives us this tuple, book.types 0 gives us the hardcover, and finally the page weight plus 100 for the weight of the book. I'm adding 100 because it's a hardcover, so it's probably going to be a little heavier than a paperback. So hopefully this makes sense. It is a little bit confusing because you are using the class inside a method defined inside the class, which I know is a little bit weird, but that is how you can create a new object inside of a class. This is something you can totally do. And because it is a class method, you no longer need to create your own object first. All you have to do now is say book.hardcover and pass in here Harry Potter and the page weight, which was 1500. Notice that this hardcover method takes in the name and the page weight, but it does not take in a type. The type is added inside the method. You don't have to pass it in as an argument. So if I save and run that, you can see that now you get a book, Harry Potter, which is a hardcover and weighs 1600 grams. Let's do the same thing for the paperback. Only now instead of book types 0, I'm going to do book types 1, and I'm going to remove this plus 100. So now, if we wanted to create a soft cover book or a paperback, you can say something like light equal book.paperback, Python 101, and you can say, for example, 600. If you then print the light book as well, you'll see that you get 2 books printed out now. Book Harry Potter, which is a hardcover, weighing 1600 grams, and book Python 101, which is a paperback, weighing 600 grams. So this is a very, very common way of using class methods. Because you have access to the class itself inside the method, that means that it is a perfect place to be creating new objects by using that class. With that said, though, notice that I am using book here, and I'm not using CLS anywhere. Book is the class, as we saw earlier on, and CLS is also the class. So they are interchangeable. Instead of book, you can put CLS in there. and instead of book down here, you can put CLS in there. You should do that. Use CLS instead of book, and that will come in handy when you look at inheritance, which we will look at later on. Just because using CLS gives you a little bit more flexibility down the line. So do use CLS there, since you've got access to it. And if you were creating a static method instead of a class method, you would have to use book class because you wouldn't have CLS. So if you want to use CLS, use a class method, use the parameter, and you can create new objects and return them or use them however you like. Hopefully this makes sense. I know that it's a little bit confusing. You're looking at class methods and static methods, and this has been a bit of a long video, but hopefully it was helpful. Hope you enjoyed it, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to start talking about class inheritance. Inheritance allows one class to take some methods and properties from another class. Let's have a look. Imagine you've got a class called device, such as a USB device or something like that, and you want it to represent just anything you might plug into your computer. So I'm going to define my init method, and then we're going to be able to give these devices names and how they are connected, such as by a USB. So I'll say connected by. Then we'll say self.name equal name, self.connected by equal connected by. And we're also going to assume that when you create a device object, that is going to represent a connected device, something that is already connected to your computer. So we'll say self.connected equal true. We are going to assume that it's connected, and we don't have to pass in a parameter for that. We can just say true here. Then we will type str, and we're going to say return f device self.name, and we're going to put exclamation mark r, and we're going to say self.connected by. The exclamation mark r calls the repr method of self.name so that it shows up as having the quotes already. So this is just a little bit nicer than putting the quotes in yourself. Then we're also going to add a disconnect method, which just says self.connected equal false, and it prints out disconnected. So you have this class device here. This device doesn't do much at the moment, but you could do something like printer equal device and call it printer and say it's connected via USB, and then you can print it out. Finally, you can also disconnect it. All right, let's press play. And you can see that you get device, printer, USB, and then disconnected. So very good. Now, let's say you want to add functionality to this class that allows it to print things out. For example, it can print a certain number of pages or something like that. This class here is not a printer. This is a device. Could be a printer, but it could also be a webcam or a microphone. It could be anything. So we don't want to add printer-specific functionality to this class. You could rename the class and turn it into a printer class, but you can also create another class that uses all of these methods and has more. And that is where inheritance comes in. So we're going to create a printer class now, and we're going to do something new, which is put a pair of brackets after it, and here we're going to put device. And what this tells Python is that you're creating a new class called printer, and it inherits from device, which means that it will essentially copy and paste all of these methods. It won't quite do that, but you will be able to use these methods from this class. So let's start by defining an init method. Now this printer object is going to need a name, just like a device, a connected by, just like the device, and it's also going to have a capacity. How many pages left of ink? Then what we're going to do is, instead of doing self.name equal name, self.connected by equal connected by, self.connected equal true, instead of doing that, which as you can see is a copy paste of this method here, we can just call the parent class, device, init method. So what to do in Python 3 is to do super.init. So super and then pair of brackets, and what this does in Python is it gets the super class or the parent class, which in this case is device, and is going to call the init method of that super class. Of course, the init method needs a name and a connected by, so we will pass in name and connected by. These are our two parameters. We still have capacity, so we will say self.capacity equal capacity and self.remaining pages equal capacity. Why am I doing two properties with the same value? The capacity is the maximum amount of pages that a printer could potentially print if it had full ink, whereas the remaining pages is how many are left after printing some. So you can think of this as maximum capacity and this as current capacity. Then we are going to define an str method, and here we're going to return the superclasses str method. And then we are also going to put in self.remaining pages remaining. Something like that. Of course, do remember to put in your quotation marks. You will need them and your f string. So now we're going to print out this entire thing. Device, printer, USB, and then we're going to say remaining pages 100 or something. And finally, we're going to put in our printer specific method, which is the print method. Here we're going to be able to print a certain number of pages. So we will say that if not self.connected, then we will print your printer is not connected. Otherwise, we're going to say print printing pages that, and then self.remaining pages minus equal pages. Of course, we do have to return here so that we exit the function if we're not connected. Otherwise, we will print this and then that, which is not what we want. So now we have our two classes, the printer and the device class. You can still use the device class on its own if you want. It is in no way related to the printer class. So the device class knows nothing about printer. But the printer class is related to the device. It knows about it. It is the child of it. So you can now create a printer and say printer USB and say 500 pages of capacity. And then you can do printer.print and print 20 pages out, and then you can print your printer. This is all a bit confusing because I've gone for the name printer, which may not be the best one, but oh well. So we forgot an f string here. Make sure to add that in. Then we're going to run it again. So you get printing 20 pages and then your device printer USB, 480 pages remaining. Here we've used inheritance to build out our methods, like our init method and our str method, by using the parent class methods, such as here and here. In addition, this printer can still use the disconnect method that was defined in the device class. And what happens when you do printer.disconnect is that Python will try to look for the disconnect method inside the printer class. But upon not finding it, it will try to look in the next parent class, which is device, and it will find it there. The device class actually inherits from another class as well, which is the default inheritance, and that is Python's object class. So if you call a method that is not in the printer or the device class, Python will then go to the object class and see if it's there. And if it's not there, then you'll get an error. So those are the three levels of calling that you will see when you use the printer class. First, the printer will be checked, then the device will be checked, finally the object will be checked, and if none of them has the method or the property you're trying to access, then you'll get an error. Let me just run that, and you can see that you get disconnected there. Of course, if you do printer.print and you try to print 30 after you've disconnected, then you will see your printer is not connected. Hopefully all of this makes sense. Inheritance in Python is much simpler than in other programming languages. All that happens is there is a hierarchy for calling things. When you try to call a method or access a property of a class, that just goes up the hierarchy. And that's it. You can always use the superclass within a class, so you can access that class's methods, such as what we're doing here and here. Thanks for joining me in this video. I hope you've enjoyed it, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about class composition. Composition is a counterpart to inheritance to build out classes that use other classes. You're going to be using inheritance very little in Python, if I'm honest. You're going to be using composition much more. Composition allows your classes to be simpler and reduces the complexity of your code overall, so it is recommended that you use that most of the time. In addition, composition means something different than inheritance when you're thinking about your classes. For example, we've got here a bookshelf class that takes in a quantity when you create it, and then when you print it out, it tells you that it's a bookshelf with X books. For example, here we're creating a bookshelf with 300 books. When you print it out, you can see that it says bookshelf with 300 books. If you wanted to create a book class now, some new programmers may be tempted to make it inherit from bookshelf. After all, they are somehow related, correct? Books live in bookshelves, so... And then you would do something like this, init, and then you would say the name of the book. But now, if you want this book to call the superclass's init method, you also need the quantity of books. So this is where this is starting to break down a little bit. A book object doesn't have a quantity of anything. So anyway, we are going to continue with our example because we firmly believe that a book should inherit from bookshelf. So you'll put your quantity in here, and then you'll say self.name equal name. Okay, perfect. Now, this, I'm sure you realize, makes little sense because you're passing the quantity to a book. So when you create a book object, you're going to have to say Harry Potter, and then you're going to have to say something like 120. Then if you print book, you'll get something out that's not all that good. You get bookshelf with 120 books when you print the book. So clearly, you're going to need an str method here that prints something completely different. So for example, book self.name. Okay, let's press play again. And now you get book Harry Potter. So why is this a bad approach? Well, there are two reasons. One of them is conceptual, the way of thinking about it. The other one is technical. The conceptual reason is that when you do inheritance, you are essentially treating it like evolutionary inheritance. You're saying that a book is a bookshelf and something more. For example, in the same way that all tigers are mammals, but not all mammals are tigers. So all books are bookshelves, but not all bookshelves are books. The bookshelf can still be used on its own. That breaks down when you talk about books and bookshelves because a book is something completely different from a bookshelf. A bookshelf can contain books, but one isn't the other. The technical reason why this breaks down is because you've got this book class that inherits from bookshelf, but actually you are not using inside it anything about the bookshelf. So you're completely overriding the str method because you don't want anything to do with bookshelves in there. And you actually don't need this at all because, I mean, what's the point of setting the quantity if you're not going to use it in the methods? So the conceptual reason is a book is not a bookshelf. The technical reason is there is no reason to inherit if you're not going to use that inheritance anyway. So this is where composition comes in. Composition is for when you want to say something like a bookshelf has many books. A bookshelf is composed of a bunch of things and books. So instead of defining our bookshelf and our book like this, we're going to define it slightly differently. Instead of setting the quantity of books in the bookshelf, we're actually going to allow the constructor to take in a number of books. So we will do star books, and then we'll say self.books equal books. And then here we will say bookshelf with len of self.books. So what this will take in is a bunch of book objects. Next up, the book class doesn't actually need... I'm going to delete this as well for now. The book class doesn't need to inherit from bookshelf, and it doesn't need a quantity, and it doesn't need to call the superclass of anything. Okay, so now we have two much simpler classes. But how do you use them? Well, we can create our book, and then we can create another book. Just like that. So we have our two books here. Then we'll create our bookshelf and give it the two books. Then we can print the shelf. So I'll press play now, and you can see that you get bookshelf with 2 books printed out. This is composition, and this is very common, much more common than inheritance. It is when you have a class that contains a bunch of other classes, or a class that has many of that. And here we've got our bookshelf that has many books, and when you use it, when you create it, you can pass to it a bunch of your other book objects. So to recap, inheritance means that a book is a bookshelf. Composition means that a bookshelf has many books. So take your pick from those two. That's an important decision to make, but as I said earlier, you'll most frequently be using composition. Thanks for joining me in this video to learn about composition in Python, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about type hinting. Type hinting is a new feature in Python 3.5, so you must be using that Python version or later in order to be able to use this. Here we've got a function called listAverage, and that takes in a sequence and returns the sum of the sequence divided by the length. You can call this with pretty much anything you want, right? You can do listAvg with 1, 2, 3. Obviously, this is not a sequence, and it's certainly not a list, so maybe if you're calling this, you'll realize that it doesn't make much sense, but you can call it. It will give you an error if you do that. As you can see, it tells you that you can't do sum of an integer or len of an integer, but while you're coding, there's nothing there to tell you that you might be making a mistake. So let's fix that. You can write inside the brackets, colon list. And what this tells Python is that this thing should be a list. After the brackets, you can type dash greater than, making a small arrow there, float. And what that tells Python is that this function is going to return a float. So this is how you do type hinting in Python. However, let me say that using the list object as a hint here is usually not recommended. Usually you'll be doing from typing import list. And I know we haven't looked at importing in Python just yet. We're going to learn about that in the next video actually. But you'll be using that and then you'll be putting that there. That's the most common way of doing it. We're going to learn about imports in the next video. So this tells you that the sequence is a list of elements. You don't know what elements. And it returns a float. Notice though that VS Code, which is the editor I'm using now, doesn't tell me that I could be making a mistake. If you're using PyCharm or if you're running a program called a linter, then that program or PyCharm will tell you, hey, you're passing in a number here, but the expectation is that you should pass a list. So that is why we do type hinting. You can type hint anywhere. So for example, you can type hint your class book. You can say that the name should be a str for a string and the page count should be an int. You don't have to specify a return value because this function doesn't return anything. Here we've got our from typing import list again. You can also import tuple, set, and there's a bunch more. And you can use it like that if you wanted to define that the books parameter should be a list of book objects, given that the class book exists, of course. So this is how you can do that. Also notice that I have signaled a string being returned from the str function, and again, that's that being used there. So the key benefit of doing this sort of stuff is that you'll get told if you pass in the wrong thing. As we learn more about Python, then we will be using these type hints more and more, so you'll see me using them every now and then in the next few videos. One more example that we've already seen, our book that has the class methods for hardcover and paperback. Now we can type hint it and make sure that when we are using this code, we get told whether the name, book type, and weight arguments that we're using to create a book are correct or not. So here we're saying that the name should be a string, name colon string, the book type should be a string, and the weight should be an integer. The repr function returns a string, and the hardcover and paperback methods take in a string and an integer and return a book object. This is how you signal that these methods return an object of the same type that you're currently in. You can't do this because it will give you an error, because this method here is created before the class has finished processing. So this is created while the class is being processed, so that's why you can't use that there. So in Python, we put them inside quotes to signal that this method returns a book object, which is the same type that we're currently in. If this returned a different class, then you would do that. Say if it returned a bookshelf, then you can totally do that. But if it's the same type that you're currently in, then you have to signal it like that. Alright, just a few examples of how to use type hinting in Python. Again, this is a refresher course, so we're not going into detail of how everything is working, but we will be using these type hints over the next few videos, and you'll get more familiar with them. They're really straightforward. It's just there to help you as a developer. They don't stop your code from running. They don't raise any errors or anything like that. It's just to help you. Thanks for joining me in this video, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about imports in Python. How to work with files, how to get code from another file into your main file. I've got two files now in my project, code.py and mymodule.py. I'm going to write some code in mymodule.py that I will then import into code.py so I can use it from there. So I've written a simple function that divides two parameters, and I'm also going to print mymodule.py colon and then underscore underscore name underscore underscore. Underscore underscore name underscore underscore is a global variable in Python that changes depending on which file you're in. So it is a special variable because it will allow you to differentiate between the file you run and a file you import. And it also does a couple more things that we'll explain as we go along. So here in my module, I've defined a function, and I've also printed out the underscore underscore name underscore underscore property, and I've also said that we're in my module.py there. So if I run this code right now, what you'll see is that you get my module.py, and then you get dunder main. Instead of saying underscore underscore all the time, I'll just say dunder from now. That's the usual Python terminology. So you get my module.py and then dunder main. So evidently, dunder name must have equaled dunder main at the time of running. Otherwise, you wouldn't have got that printed out. So let's say that when you run a file, the dunder name variable equals dunder main. Because we've ran my module.py, that's why that value is there. If we go over to code.py now, we're going to do from my module import divide. And this is how you can import a specific thing from another file. So here we're doing from, and then the file that we want to import from, and then import and the thing that we want to import. Alternatively, if you don't want to import a specific thing from the file, then you can just do import my module. And then, as usual, you would access the divide function inside my module by doing my module.divide. If you wanted to do that instead, that's also totally fine. There are some subtle differences between the two types of import, but they are subtle, so you won't come across them very often. We're not going to cover them in this course. Now that we've imported the divide function from my module, we can use it as if it were defined inside this file. So I will do that. Then I'm going to run this file. And you see that we get two pieces of output now. We get my module.py is my module, and you get 5.0, which is the result of dividing this here. And here is the interesting part. Notice how earlier my module.py printed out dunder main, but now it has printed my module. That is because only the file you run is dunder main. So if we print dunder name here and we run this again, you'll see that you get dunder main printed out inside code, but my module.py is still printing out my module. So the file you run is dunder main, and as soon as you import other files, Python will name them according to their path. So my module here is at the top level of our folder, so the name will be my module. So how does Python know where my module is? Does it just look in the current folder? Well, the answer is in import sys. Import sys allows you to use the sys module that comes with Python, and that unlocks some certain system functionalities, and one of them is sys.path. So sys.path is the import paths where Python will look in order to find files to import. So I'm going to press play now, and you can see that you've got a whole bunch of different paths here inside a list. The first path that Python is going to look at is the first one in this list, which, as you can see, is this 29 imports in Python folder that we are currently in. So whenever you try to import something called my_module, Python is going to go into this folder first and see if something called my_module.py is in there, or indeed a my_module folder. And if it is there, it will try to use that. If it's not, then it will go into the next path, and then into the next one, and so on. If it reaches the end and nothing was found for that name, then you'll get an error, an import error. For example, if I try to import sysasdf, you're going to get an import error saying module not found, no module named sysasdf. These paths are defined in a specific order. So the first path is always the path of the file you ran. So here we've ran code.py, so the first path is the path to code.py, except of course the file name. So whenever you run a Python file, you will be able to import other Python files or folders inside the same folder that you ran. The second path, if defined, is an environment variable called Python path. At the moment, we don't have a Python path defined, so that's not there. And then you've got all your other paths for your imports that are defined at a Python level. In Unix systems, you can do export Python path and then give it a path. For example, you can do /users. Then if you run this code again, you'll see that the second path now in sys.path is the /users path. Again, the first path will always be the one that you currently ran your file in, and the second one will be your Python path if it is defined, and finally the rest of your paths. In Windows, instead of export, you'll have to use the keyword set to set an environment variable. Let's go back to importing my module, and now from my module we're going to import something in a folder. So here in my project, I'm going to create a new folder. I'm going to call it libs for libraries, and inside that folder we're going to create a library called mylib.py. Mylib.py is going to contain just mylib.py and then dunder name, just so you can see how the dunder name operates. Here in my module, we're going to import libs.mylib. And then here we're going to import my module. So the imports go code imports my module imports libs.mylib, and then mylib prints out the name. Let's run this and see what happens. So as you can see, we got my_module.py imported, and the name at that time was my_module. And then that imported mylib.py, and the name was libs.mylib. So again, it is the path that you use for importing that is relevant. If you're using Python 2, then this will not work, because in some Python versions, you have to also create a dunder init file inside any folder that you want to import from. So here in the libs folder, I have created a __init__ file. I would recommend you get accustomed to creating those files because they are sometimes required. After doing all those imports, you can actually check sys.modules to see what's imported. So I will also import sys from here and press play. And then you can see that there's a bunch of things that have been imported at the time. So you have all of these built-in modules, including the sys module that has a bunch of other things, frozen import lib, and there's loads of different ones that already come with Python and you can use. And then at the very end, you've got your own. So you have libs.mylib, libs, and my_module. And these are all imported by the imports that we've written. So whenever you type another import somewhere else in your program, Python is going to check these modules and see if that import is there. And if it is, then it's going to use that instead of trying to import again. Why does that matter? Because as you've seen, when we import a file, such as import my_module, it runs through the file in order to be able to determine what is inside the file that we can use. So if you were to import the same thing many times, and every time you ran that same thing, you might find that your code is running a lot of times over and over without achieving anything. That's why Python keeps track of the things that have already been imported, and if they have, you won't run through them again. You'll just be able to use the one that's already ran. Hopefully that makes sense. To recap, importing runs through a file and allows you to access the properties defined inside it. The dunder name variable is equal to dunder main in the file you run, and is equal to the import path on other files. And you can import from files or folders as long as they are in your sys paths. Importing from a folder usually requires a dunder init.py file to be defined, especially in older Python versions. Thanks for joining me in this video. Hope it's been useful, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to talk about relative imports in Python. And this is something that's really confusing for new Python beginners. And to be honest, it's a bit weird, and you're not going to be using them very much at all, but I just wanted to talk about them so that you won't use them precisely, because they work very differently than what you might expect. What I've got here is 4 files now. I've got code and my module in the same folder. Then we've got our libs folder that contains mylib, and then we've got our operations folder that contains operator. So code imports my module imports libs.mylib, and mylib imports libs.operations.operator. And each one prints out their name. So if we press play right now, what you get back is, well, first of all, something important to notice that I may not have mentioned in the last video is that when you run the import, that immediately jumps into the next file and starts running it. So, of course, code.py imports my module, so that stops code.py from running, and Python jumps to my module. This imports mylib, so this stops running and jumps to mylib. This imports operator, so that stops running and jumps to operator, and that prints. Then we go back to mylib, and then we print. Then we go back to my module, and then we print. And then we go back to code, and then we print. So that's why the order here is reversed from the order in which the files are running. Code is running first, but that prints out last because of that tree of imports that's going on. So this is not relative imports. These are just absolute imports, where you have to define the path that you're importing from. So here, the path is libs.operations.operator, and we're doing from libs.operations import operator, or you could do import libs.operations.operator if you preferred, although then you would have to access things like libs.operations.operator.divide if a divide function was defined inside that file, which is not. At the moment, nothing's defined inside these files. They're just printing out their names. So that is absolute imports. Let's talk about relative imports. A relative import is one that can import from the current folder that the file is in. But it cannot import unless there is a folder name in the import path, in the module path. So here's what that means. libs.mylib, when it prints out the name, you can see that there is a folder inside the import path that is separated from other things in the path by a full stop, a period. So here you've got the libs folder, and inside it you've got the mylib file. You can tell this is the file because it's the last thing in the import. Similarly, the operator.py has a file, operator, that's where we're importing from, and 2 folders, operations and libs. So from these 2, you can do relative imports because there is a folder. From these 2, you cannot do relative imports because there's no folder. So let me show you what happens if you try to do a relative import and you don't have a folder. In order to do a relative import, you need to use the from syntax. So you can do from .mymodule import divide, let's say, and I'm going to just add a divide function here. So I've added a divide function there that doesn't do anything, and we're going to try to import it from .mymodule. So what that means is from the current folder, look at the mymodule file and import the divide function. So that makes sense because my module is in the same folder as code.py. You can see down here, they are in the same folder, so this should be fine. But when you try to do that, what it does is it tries to import from dundermain.mymodule. So as you can see, because the name of this file was dundermain and it doesn't have a folder, it tries to import from the current place it's in, and Python won't let you do that. So if you are importing from the file you run, you can't use relative imports. Going into mymodule.py, you could do from .libs import mylib. And what that's going to do is it's going to try to access the libs folder inside the current folder. That's what the dot means. But again, if you try to run this code, you're going to get that you attempted a relative import with no known parent package. Again, my module has no information about the folder it's in, so Python can't do a relative import from it. I'll show you again these paths here, because what you've got, I'll run code.py so it's the same as before. What you've got is that my module and main are at the top level. When you're trying to do a relative import, what Python is going to do is it's going to remove the file and it's just going to try to append whatever you import from into the rest of the import path. So if we go to mylib and then we do from .operations import operator, what that's going to do is it's going to say, okay, mylib, you are inside libs.mylib. So because you're trying to do a relative import, we're going to remove the file and we're gonna try to put operations at the end and import from there. So here it'll work because it'll do libs.operations and then it'll import operator from that. So if I run code.py again, you can see that it all works fine. There's no errors whatsoever. However, if by any reason you want to run your mylib file, for example, to debug it or run some code inside it, make sure it works or something like that, you won't be able to because, of course, this now becomes main if you run it, and then you can't use relative imports from inside it. So if you are going to use relative import, you always have to run the same file at the top level, otherwise you may encounter some issues. Going into operator.py, you can actually do from .mylib import star, let's say, and what this does in Python is it accesses the parent folder. So again, if operator is inside libs.operations, dot is going to try to remove the upper parent and go direct to the previous one. So it'll try to do libs.mylib. That's what the dot means. It just skips the parent folder and goes up to the next one. So, of course, in order to do that, you need to be at least 2 levels deep. Otherwise, if you're trying to do that, for example, from libs.mylib, you're going to try to skip libs and go to the previous one, but there is no previous one, so you'll find an error. So again, in order to do this, you need to do something like that, and that, you can see, works totally fine. Let's go back to why we didn't print anything else out when we ran this code, because as you can see, this output is exactly identical to the one we had before, so it seems that this did nothing. But really what's happened is Python has realized that libs.mylib had already been imported by my module before we imported operator. So it didn't try to import it again. This just reuses the import that's already on sys modules. So that's why we didn't see any more output. mylib.py didn't run again when we tried to import this. It was already in sys.modules. I also wanted to say that at any point in time, if you wanted to import, say, operator.py from my module, you can do import libs.operations.operator, or of course, from libs.operations import operator. You can do that as well. By the way, this just means import everything that is inside this path here. So if there were multiple functions, you would import them all. If there's multiple variables defined in there, you would also import them, and so on. Alright, that's everything for this video. Thank you for joining me. I know this stuff is confusing, but my advice is to not use relative imports in Python. They are difficult to understand, they're confusing, they only work if you always run the same files, and they won't work if you try to run other files, such as the ones that use relative imports for debugging or to try things out. So don't use them, use absolute imports instead. Your life will be much easier, and really you're not going to encounter any problems with that. So thanks for joining me, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about errors in Python. What we've got here is a simple divide function that takes in two parameters. If the divisor is equal to 0, it prints that it cannot be 0 and then returns. Otherwise, it'll return the dividend divided by the divisor. If we run this code, you should see that you get a print, divisor cannot be 0. However, if you use this function inside a program, potentially you may encounter a problem, which is that your program expects the function to work, and there's nothing in the function that says otherwise, other than a print statement, which really is meant for your users to see. For example, let's say that we've got a set of grades, and we want to calculate the average. And we have a program like this one. Welcome to the average grade program, and the average is equal to divide of some grades by len grades. Obviously not the most useful program, but just bear with me while I explain why errors are useful in Python. What we're going to get here, if we run this program and we print the average grade is average, is of course, the average grade. It says the average grade is 90.5, that's it. So, very good. However, if we want to print a nicer error message, we start having to do some pretty crazy stuff if we are not using errors. For example, let's say that we don't have any grades yet. For example, imagine our program adds the grades over time or something like that, and there are no grades. What you'll get is, welcome to the average grade program, divisor cannot be 0, the average grade is none. So not the greatest functionality here in our program, and this is caused by this function printing something out that is essentially just mathematical. It's unrelated to the context of the program. This program here talks about student grades, and that's what the user is expecting to read about. This program here, or this bit of code here, talks about mathematics, whether you can divide a number by 0 or not. So they are related, but you don't want to be printing divisor cannot be 0 when the user is expecting an average of a bunch of grades. However, it is the only way that we can do something unless we check for the divisor being 0 out here. So if we say if len grades equals 0, then you can say you don't have any grades. You don't have grades yet, right? So we could do this instead. And then if you want, you can also put that same check here. You don't need this return. So as you can see, this is getting a little bit messy now because you are removing logic from a division function that really should be in there, or could be in there, and putting it in your main program is making your main program longer, it's making your function shorter, but it's doing a bit less. This function here could check for division by 0 and then do something a bit more useful rather than print things out. So here come the errors. In Python, errors are often used for flow control, very much like if statements. So by allowing your functions to raise errors, you're going to then be able to catch them in your code and handle them. So here's what we're going to do. If divisor equals 0, now we are going to raise something called a zero division error, which is an error that comes with Python. And you're going to say divisor cannot be 0. Now, this message here inside the brackets means that this error is going to have a message attached to it. And what we're doing here is we're saying raise, the keyword raise, and then a space, and then the exception name or the error name. Exceptions and errors are the same thing. And then the bracket. So we're creating an exception object in here. This is another class that is defined inside Python. So if we try now to divide the sum of grades by the len of grades, knowing that there are no grades, what you're going to get is welcome to the average grade program, and then you're going to get a very nice traceback. So let me just make that a bit bigger for you. A traceback shows you where the problem happened. And here it says that the last set of lines here tells you where the error originated. And it says it originated in code.py, which is our file, line 3, which is this one here, in the divide function. And the problem was that you raised the error yourself. So because you raised an error, the error happened. If you didn't raise the error wouldn't have happened. So that is what it's telling you there. And then it's saying that the next thing up, what called this divide function was this line here, line 11. And it's showing you the line there that caused this function to be called, which then caused the exception. So you can see how it bubbles up. And in our case, it's only got 2 lines here, but sometimes these can be really long. And it can tell you this called that, and that called that, and that called that, and so on, and eventually an error happened. And what you've got at the very end is the error itself, a 0 division error. Divisor cannot be 0. Clearly, we don't want to be showing our users this, but this is excellent and really helpful for when you're coding. So errors help you track down problems and where and why they happened. So errors give developers a great tool for debugging or finding where the problem is. So that's one great plus of using errors. The other thing is that now you can catch the error. You can say, okay, if an error happens in this line, I want to do something. And the syntax for that in Python is a try except block. So we're going to try to do that. And then if a 0 division error happens, then we can print there are no grades yet in your list. So try, and then in an indented block, we put the code that we want to try. This can be 1 line or it can be many lines. And then in the same indentation level as the try, we put except and the type of exception that we want to look out for. If this exception happens in this code, then we will run this stuff here. So now our code can handle this 0 division error, meaning that if we get a 0 division error, we are not going to print the traceback. We are not going to print divisor cannot be 0. We're going to print there are no grades yet in your list. However, if you use the divide function somewhere else in your program and you don't wrap it in a try except block, the error will still happen and divisor cannot be 0 will still be printed out. And the traceback. So this allows you to handle these errors in different ways throughout your program, which means that this divide function is concerned about the mathematics of division. This piece of code here is concerned about how to handle the mathematics in the context of your program, which is there are no grades yet in your list. Notice that here in the except block, you can do as e, and what this does in Python is it creates a variable called e and puts inside it the value of the error, if there is one. So if the 0 division error is created with this message, then e will contain that. And e can be anything you want, so you can call it exception, or you can call it e, or you can call it Bob if you want. You know? And we can print e as well if you like, just to see what happens. And what you get is this stuff. So you get there are no grades yet in your list, and you get divisor cannot be 0. Afterwards, because there was an error in this line, the average variable was never created, because this caused the error, which means our code jumped directly here. So when you run line 17, the variable does not exist. Therefore, you may want to put your variable in the same block as your variable definition. Now running that will give you, welcome to the average grade program, divisor cannot be 0, there are no grades in your list. If you remove this print e, then that'll get rid of the divisor cannot be 0, and you'll get, welcome to the average grade program, there are no grades yet in your list. So this is exactly what we wanted, and using errors allows our program to handle both the maths of the operation and also the program context. As well as 0 division errors, there's a whole bunch more built-in errors that come with Python that you can create for different things. All errors are handled the same way, but when you see in your program that a 0 division error has happened, it tells you that you probably tried to divide something by 0. So there are other types of errors so that you as the programmer can more easily tell what happened and what went wrong. Some examples are a type error, or when something was the wrong type and you would raise a type error. That you got value error for when something had the wrong value or an unexpected value. You've got runtime error for most other things. And you can also create your own errors. So we're going to be doing that in the next video. Finally, instead of putting this line of code here together with the try, you can actually put it afterwards, but tell Python to only run it if this succeeded. So the way you do that in Python is you put an else, actually, in there, and you put this line of code in here. So this is a different way of running that same code. And what happens here is you try to run this. If an error happened, then you run this. And if no error happened, that means that this line of code ran successfully, then you run this. So the reason why we may want to use the else instead of putting this line of code here is if we want to catch some specific errors in a specific line of code and we don't want to put all of our code in the same block. Finally, if you want to run a piece of code always, no matter whether there is an error or no error, you can use the finally clause here to print something else out, or indeed to do anything else. So these are the different clauses: try, except, else, and finally, and they run in that order. You can have multiple except clauses if you want. For example, if this function here could raise a zero division error, or potentially somewhere else it could raise a value error, you can catch them separately and handle them differently if you want. I'm just showing you the syntax there, but we're going to look at some examples in just a moment. Imagine you have a list of students and each one has a bunch of grades. Here is when using this function might come in handy, because you've got Bob, Rolf, and Jen, and Rolf doesn't have any grades. So we can try to iterate over the students list, get the name and grades, and calculate the average for a given student, printing their average afterwards. Of course, Rolf's average will fail. So we can accept in a zero division error and say error, Rolf has no grades. Otherwise, if all of them have grades, we can print that all the student averages were calculated, and finally at the end, no matter what, we can print the end of the student average calculation. So if we run this, we will encounter an error, we will print Bob's average, and then Rolf will error us out. So Bob averaged 82.5, and we get an error, Rolf has no grades. But if we put a grade for Rolf, and we press play again, now you see that all of them run to completion, and we get back a message saying that all student averages were calculated, because that's in our else. So to recap, the try allows you to run a piece of code, then you can catch or accept some exception, or multiple exceptions if you want, handling them in that block of code. The else keyword, together with try and accept, allows you to run some code if there are no errors. And finally, you can run a piece of code at the very end, no matter what, whether there's an error or not, in case you want to print a message or do some cleanup at the end. That's it for this video. Thank you for joining me, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about custom error classes and how they can be helpful. Let's say we've got a class book that defines an init method and sets three properties: the name, the page count, and the pages read. Note that I have used type hinting here to tell me that the name should be a string and the page count should be an integer. I'm going to also add a couple other methods here just to review what we've already learned. The repr method that will return some information about the book in a format that will allow me to then recreate this book, so it contains all of the information about this book. And by the way, you can put a return statement in multiple lines by using brackets and like that if you want to return a longer string and you don't want your code to be too long. Something like that. If I put it in a single line, it would be too long and I would have to scroll in order to read it. Then I'm also going to make a read function that allows me to read a bunch of pages. So I will allow it to take in that argument and say self.pagesRead plus equal pages. And then I will print out a message saying, you have now read that number of pages. Perfect. So this is a simple book class that allows me to create new books. For example, Python 101 can be a book called Python 101, and it may have 50 pages. And then I can do Python 101.read 35. And then I'm going to also read 50 pages. So clearly you can't do that, right? Because it only has 50 pages. You can't read 85 pages. But what happens if we press play? Well, you have now read 35 pages out of 50, and then you have now read 85 pages out of 50. Not great. So we are going to use errors instead in order to prevent that from happening. So here in the read method, just before we add anything to pages read, we're going to say if self.pagesRead plus pages is greater than self.pages, then we're going to raise an error and we're going to say too many pages read error. And in here, we're going to put in the message. So we'll say something like this. Of course, this error is not built into Python because it's a bit too specific for our program logic. We could use something like value error. After all, this pages is the wrong amount given the context of our program, but it's not really specific enough. So when we are getting an error back in our console, it may be helpful to have a slightly nicer name. So what we can do is, before the class there, I usually like to define my errors at the top of the file, but it doesn't really matter. You can put them at the bottom if you want. We can say too many pages read error, and we're going to make it inherit from value error. You can inherit from any built-in exception or error, if you like, in order to make it an exception class. If you don't inherit from an error or the exception class, then you won't be able to raise it because these classes have some methods inside them that you need in order to be able to raise them as errors. So you can create that, and you actually don't have to do anything inside it because it already takes in a message and all that. So you can just put pass, and this too many pages read error will essentially just be a copy of value error but with a different name. So now when we raise this error, we're going to get a nice message there that says, too many pages read error, you try to read 85 pages, but this book only has 50 pages. In addition, you get your traceback, which tells you where the problem was, which is that you tried to read 50 pages there, but you'd already read some before. When you're looking back through your code, you can very easily determine whereabouts in your code the problem happened, and you can read through it and try to find out what the problem was. Now, of course, this isn't great for users, so if you wanted to print a nicer message, you can always try to do that, and if not, accept it and print the message on its own. Just like that. That's it for creating custom classes. It's really very straightforward. You just inherit from the most relevant built-in error class, like value error, runtime error, or even type error, and you name it as you would like. That gives you a slightly nicer name and the ability to find your problems a bit more easily. Most of the time, you don't have to put anything inside the error classes, just giving them a new name is good enough. But you can do if you want. We're not going to cover how to populate the body of your custom error classes in this course, though. That's a little bit more advanced. Thank you for joining me in this one, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to learn about first-class functions. A first-class function just means that functions are just variables, and you can pass them in as arguments to functions and use them in the same way that you would use any other variable. Let's get started. Here we have a divide function that raises a zero division error if the divisor is 0. We've seen this before. And then we have a rather weird looking function, calculate, that takes in any number of arguments and collects them into this values tuple. We've seen this before, and if you can't remember how this works, please look at the Unpacking Arguments lecture. Then it also takes a mandatory keyword argument parameter. So that is operator. And then what it does is it calls the operator function with the values. So that's kind of weird. How does that work? How does it know it is a function? Well, the simple answer is it doesn't. However, because we've got these brackets after the variable name, this here must be a function, since that is the syntax for calling a function. So we're calling this operator variable as a function with the values passed in as individual arguments. How would we use this calculate function? You could do something like result equal calculate, and then notice that calculate takes in any number of arguments. So we're going to type 20 and 4, and then we're going to type operator equals the divide function. So this will pass in the divide function as the operator, and then we will only call it when we reach line 9. Notice that this divide function is not called here, it is only used as a value. If you wanted to call this function, you always have to put the brackets at the end. That's how you call a function in Python. So by not putting the brackets, you are passing in the value to which this name divide refers to, which is the function, as the value for this parameter. So the operator parameter now has the same value as the divide variable. They are both this function here. So you can call it as a function, passing in the values as individual values. So that will give you 20 for the dividend and 4 for the divisor. This here is an example of using a first class function, because you can see that you can pass it in as an argument to another function. Functions in Python are just variables that happen to be callable. You can call them with the brackets at the end, but they are no different than any other value other than that. So now you can print the result if you like, and you'll see that that has indeed called the divide function, and you get 5.0. If you change this to a 0, though, you will end up with a traceback because you tried to divide by 0. Something important that will be a little bit of a problem in this code is that the calculate function takes in any number of values, but this operator expects 2 values. So if you put any more, then you will also get an error, because now you're going to pass in too many positional arguments. See, divide takes 2 positional arguments, but 3 were given. So that is a small problem with this code here, but anyway, the point of it was to show you how first-class functions work. Let's do another example. I'm going to define a search function that takes in a sequence of things to search through. It will also take what you expect to find, and finally, it will also take a function that will be used to extract information from each item in the sequence, match it against the expected value, and see if we find what we wanted. So we will iterate over the sequence. Then we will run the finder function on the element and see if it is equal to the expected value. And if it is, we will return the element. Otherwise, we will raise a runtime error, saying something like, could not find an element with expected. So this is a little bit of a confusing function there, because it uses some parameters together with other parameters to find a third parameter. So a little bit weird, but let's say now we have a list of friends, and we want to find out which friend is called Bob Smith, which here it doesn't exist. The first thing we have to do is we have to define a function that will run on one of these dictionaries and give us back the name. So we will say get friend name, and we will make it take one parameter, and we'll say return friend name. So here we have a function that if we run it on an element in this sequence, will give us back the name property of that element, be that what it may. Remember, this may fail if the element doesn't have a name property. Then we're going to print out the search, which is this function up here. We're going to pass in the friends as our sequence. So this search function is going to iterate over our friends. Then we're going to look for Bob Smith. And finally, how we're going to extract that value from each element is going to be by the get friend name function. So just to recap, get friend name will be the finder function. So that will run on each element. For example, for the first one, it will run on this dictionary here, and it will give you back the name property of that value. So you'll get back Rolf Smith. So Rolf Smith will be here, and you will compare it with the expected value, which is Bob Smith. If they match, you will return that element, which is this dictionary. The same thing will happen for all the other ones. At this point, we don't have a friend called Bob Smith, so by running this, we will get the runtime error. Could not find an element with expected. However, if we change this to Rolf Smith, then you will get it to work. The name is Rolf Smith, and the age is 24. This is quite a confusing bit of code, but is a prime example of how first-class functions can be useful. So I would recommend giving it a go, playing around with it, see if it makes sense. And if it doesn't, please ask a question in the course Q&A. Of course, we're always happy to help. This is also a great place to use a Lambda function. So instead of using that function, you can just define something like this. and just create it there where it is used. This is an alternative. No one is better than the other. You can do what you prefer. The other one's slightly longer, but it does have a nicer name because you get the function name and it tells you what it does. So that's a good thing as well. Finally, you can use neither of these two. You can not define your own function or use a Lambda function. You can just use a built-in from operator import item getter. And here, instead of this Lambda function that is used to get a property of a object, you can use item getter with name. And that does exactly the same thing. This here is a function that creates a function and lets you use it afterwards. So this is a little bit more advanced. We're going to learn more about functions that create other functions later on. So there you have it. That is the same thing. As an aside, the operator built-in module, in fact, quite a few of the Python built-in modules are amazing and really useful. Alright, that's everything for this video. I hope you've enjoyed it, I hope you've learned something, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to start learning about decorators. Decorators are great in Python because they allow us to very easily modify functions. So let's learn more about them. Here we've got a user dictionary that has a username and an access level of guest. Let's say that guests can't access this function here, getAdminPassword, which returns the password to your admin panel. But as you can see, if we print out getAdminPassword at the moment, even though we're a guest, we're going to get out 1234. There's nothing in this function to prevent us from doing that. So the output of this video should be to get this function secured so that people that are guests cannot get the value out. Now, of course, the clear thing that you can do is to put an if statement in here. If the user's access level is equal to admin, then you can print out this function. Otherwise, you can't. So this will work. If you run that, you don't get anything. But of course, as you know, getAdminPassword is still unsecure, so you can still print that out and it will still work. Because what we've done is we have protected this specific call to getAdminPassword, but we haven't protected this one. So this is probably not exactly what we want to do. The next thing we can do is we can define a secure function. For example, secure getAdmin. And in this one, if the user's access level is admin, then we can return the password 1234. Now, a couple of things. Clearly, getAdminPassword is still defined, so that is not going to work. But secure getAdmin does protect the password. So running that gives you none, first of all, when you run secure getAdmin, because we didn't return 1234. Instead, we returned none, which is a default. Then you get 1234 the next time around. So, of course, what you may want to do is delete this one entirely. But that poses a small problem, which is that all the functions where you want it to be secure, you're going to have to add this if statement. And up till now, that is what you would have done if you didn't know about decorators. But a decorator will allow us to modify this function to secure it without having to replace all of our functions by its secure counterparts. So we don't want to do that either. Instead, what we could do is define another function, secure function, that takes in a function. We've learned about first-class functions, so we can take it in as a function in there, and we'll say if the user's access level is equal to admin, then we will return func. Otherwise, we'll return none. And now what you may be tempted to do is to do something like getAdminPassword is equal to secure function getAdminPassword. So, will this work? Well, let's run through the code. We've got secure function being called, which takes in getAdminPassword, and when this line runs, we're going to check the user's access level and see if it's admin, and if it is, we're going to return func. So, let's see what happens. Now you get an error. None type object is not callable Because of course, when we ran this code, i.e. this line here, the user's access level was guessed, not admin, so we didn't return func. We returned none, which is the default, so getAdminPassword equaled none. Then we try to run none as if it were a function, but you can't do that, so you get an error. What you would have to do is make sure that your user is an admin before you run any of your code, and then it will work and you will get 1, 2, 3, 4. So this is a step closer to what we want, but alas, it requires that our user be an admin before we secure our functions. Ideally, we would like to do something that checks the user's access level when you call the function, not when you define it. So here's what we're going to do. We're still going to take in a function, but now we're going to define another function, which I'm going to call secure function. This one I'm going to call make secure. This one doesn't take any parameters, and it is the one that checks. And it returns calling the original function. Then, here we return secure function. So this is a decorator. What happens now, and by the way, this should be make secure. What happens now is that getAdminPassword, this function that we want to secure, is passed to the make secure function. This one defines another function. And by the way, in Python, you can define functions inside of functions. That's totally fine. And this function here, when called, will check the user's access level and return calling the original function, which is getAdminPassword. So it will return 1, 2, 3, 4 if the user's access level is admin. So that's this function here. And then we return the function itself, not the function call, but the function itself. So getAdminPassword will be equal to this function, which calls seemingly itself, but this is okay. It calls getAdminPassword from up here. So when you call getAdminPassword, what you're going to do is you're going to check the user's access level, and then you're going to return the result of calling the function originally, which will give you 1, 2, 3, 4. At the moment, you get none, but of course, if you set the user's access level to admin down here, and you run it again, then you get 1, 2, 3, 4, which is exactly what we wanted. So this is a simple decorator. This simple decorator will create a function and replace the original function with the secure one, so that you can no longer call getAdminPassword without having the admin access level. Now, if you wanted to add a little bit of error handling, you can do an else here, and you can return something like no admin permissions for username. And that'll give you a nicer idea of what's going on if you don't have admin permissions. That's everything for this video. This is a simple decorator. And now in the next one, we're going to learn more about using the @ syntax for decorators that makes this much simpler and much easier to reuse and secure multiple functions if that's what you want to do. Thanks for joining me, and I'll see you in the next video. Hi guys, and welcome back. Let's look at the @ syntax for decorators. Here we've got our code from the last video. We have our make secure function that defines an inner function that will be used to replace the function that we want to make secure. This function checks the access level and then returns a call to the original one, such as the getAdminPassword function. Now, I'll have you know that instead of doing this, getAdminPassword equal make secure of getAdminPassword, which can have some problems, for example, if you decide to call getAdminPassword before that line runs, you can use the @ syntax, which does exactly the same thing. That is @make secure. If you put @make secure in front of or on top of a function definition, that will prevent the function from being created as is, and instead it'll create it and pass it through the decorator in one go. So you no longer need that here, and now you'll see that if we run this code, you will get no admin permissions for Jose, because at the moment I am a guest, but if I change this to an admin, then it'll all work out. However, there is a small problem with decorators as a whole, both when you assign them and also when you use the @ syntax, which is that when you replace this function by this one here, the name of the function changes. So the getAdminPassword, it still exists as a name inside Python, but it is no longer registered as a function internally. Now the secure function is registered as a function internally, and there are some libraries that will actually use that internal name. So for example, if you print getAdminPassword.name, you'll see what I mean. The name of getAdminPassword is actually secure function. So that is a bit of a problem that we have to solve. In addition, if you had any documentation attached to getAdminPassword, it would also be lost when you replace it with secure function because this one doesn't have any documentation. To fix that problem, all you have to do is actually use another decorator. So we're going to import functools, which is short for function tools. This is a built-in module in Python. And then we're going to decorate our secure function. We're going to say @functools.wraps. And now we're going to tell the secure function that it is a wrapper for func. And therefore, what this does is essentially it keeps the name and the documentation of this function, if there are any. So the name is always going to be there. If we now run this code, you can see that getAdminPassword is what comes out. So that's what the functools wraps is for. You'll need that on pretty much every decorator you write, so do get accustomed to using that. Remember, you want to put it on top of the inner secure function, not on top of this makeSecure decorator. Some terminology at this point, by the way, the makeSecure function is called a decorator because you can use it to decorate a function. This here is not a decorator. That's just the function that will replace your other one. Alright, that's everything for this video. I wanted to show you the syntax for decorators and also functools wraps. Those two are essential when you're working with decorators in Python. Thanks for joining me in this one. Hope you've learned something, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to learn about decorating functions with parameters. So let's take a look at our example and do a little bit more with it. Here we've got our makeSecure decorator and our getAdminPassword function. If instead of getAdminPassword, we wanted to change this to getPassword and take in a panel decorator and then do something like if panel is admin, then return 1234. Otherwise, if panel is billing, then return super secure password, something like that. Now, of course, when you call the function, you're going to have to pass in a panel, such as billing. But this function actually won't take in the argument because our function here calls the original function without the argument. So here's what's going to happen when you call getPassword. Remember, getPassword is replaced by secure function. So secure function at the moment does not have any parameters, so you won't be able to pass billing to it. In addition, when you call the original function, no argument is passed either, so even if this function took the argument in, it wouldn't be passed in there. So obviously we have to fix that. We have to put the panel in there and the panel in there. Then what happens is billing gets passed to secure function, then it gets passed to the original function, which is getPassword, and then this will work. However, this is not good because we have coupled our makeSecure decorator to this function. That means that we can't use it on other functions that take in different arguments. So instead, what you usually do with decorators is you make them take unlimited numbers of arguments and keyword arguments so you can cater for everything. The way to do that, as you may know already, is *args and *quargs, and then you just pass them on as well to the original function. So that will make it work, and also it won't limit you to using it with only this function. You can use it with any other function. This getPassword here must still be called with the correct arguments for the original function, but this one here doesn't care what arguments are passed in. That's everything for this video. Thank you for joining me in this one, and I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to learn about decorators with parameters. So this is slightly different than the last video where we looked at decorating functions with parameters. Now we're going to add parameters to the decorators themselves. Let's get started. Here we have our make secure decorator, and now we are looking at two different functions. One, get admin password, that is decorated, and get dashboard password, which is also decorated. But now I want the get admin password function to only be accessible by admins, and the get dashboard password to only be accessible by users. So if you're a guest, you will get access to neither, but if you're a user, you'll get access to this one, and if you're an admin, you'll get access to this one. So how do we do this? Well, we have a make secure decorator here, and notice that when this gets called, what happens is the make secure decorator gets applied to get admin password, but there are no brackets after this make secure. So what we're going to do is we're going to create a function that will return the decorator, but it will allow us to check for the access level. So here's how that's going to go. It's a little bit complicated. We're going to create another decorator, and this one is going to take in an access level. The rest of all of this is going to go inside that, and this one here is going to return make secure. So we have added a third level of function, and I know this is quite confusing, but now what we've got is not really a decorator. So I'm going to actually change the name of these functions, because the outer function is not really a decorator anymore. This one here is a decorator now. This one is a factory, essentially, a function that is used to create a decorator. So what we have is a function call that we give it an access level, and then it creates a decorator and returns it. So now we have to put the brackets in here. And the order is very important. The function call happens first, and then the result is applied as a decorator. So the function call happens first. This will run in its entirety. We will define the decorator function, and we will return it. Oh, sorry, this should be decorator there, because we want to return that function. So this will run and return the decorator, and that is the result of calling make secure, and then we will apply that decorator into this function. So at the end of the day, the result is the same, but now we can pass in something like admin in there and something like guest in there. Notice that because this factory does take in an argument, you need to put the argument and the brackets in there. The benefit of that is now inside here, we can check that access level. So we can say that if the user's access level is equal to the access level that we want to secure for, then we have access to the function. Otherwise, we can say that this user has no access level permissions for that. So there are no access level permissions for that user. So now if we want to run these functions, we can do. Here I've got the get admin password and get dashboard password. We should get no access for either of those. And then I'm going to change the user to an admin and run them again. And now we should allow this one, but not that one. Let me save that and run it. And you'll see that you get that problem exactly. Indeed, we actually have access to the user dashboard there. We want to change that, make sure that's for users only, since that was the original intention. Let's run that again. And you get no admin permissions for Jose, no user permissions for Jose, but Anna does have admin permissions, but no user permissions. Something that you may want to look into to improve this further is instead of using strings for your access levels, you can use integers. So guest can be 0, user can be 1, and admin can be 2. And then instead of checking equality here, you can actually do greater than, and that'll let admins access the user passwords as well if you want that. But that's it for this video. I wanted to show you how to create decorators that have parameters, and I know that they are a bit confusing. There are 3 levels of functions, which make these the most complicated Python code that you'll see in most Python courses, and certainly throughout your programming as well. But hope you've learned something, hope you've enjoyed it, and I'll see you in the next video. Hi guys, and welcome back. In this video and the next, I wanted to talk with you about mutability in Python and how it can affect your programs. It's a very important part of Python to know about, so let's dive right in. Here we've got a list, and we have given it the name A. Then we have created the name B, and made it equal to the value of name A. This way of saying things that I'm saying right now is very important, because you'll see quite often people say you created a list called A and then you created a list called B. That's not correct in Python. A and B are names. The value is this list. So if you print the ID of A and then you print the ID of B, and in CPython, the Python version that I'm using and that most of you will be using, the ID function, when you give it any object, such as this list, will give you back the location in memory of them. So by running this code here, you can see that the output is exactly the same. That means that A and B are names for the same object, the same thing. Indeed, you can see that being the case if you just do a.append 35, and then you print A and print B. If you do that, you'll see that both A and B change when you modified A. You appended 35 to A, and both A and B ended up with 35. That means that both A and B are references to the same object, this one list. However, if you did B equals another list, then this would be different now. You have one list that has 35 in it, and the other one that does not. In Python, this is the syntax for creating an empty list, so both of these are created separately and they are stored separately. Once again, going to the ID, you'll see that these are indeed now different numbers. So let me play that, and you can see that you get two different numbers. You can compare the last couple of digits there. So the fact that you can change a list after you have created it means that a list is mutable. You can mutate it. That's the same thing as changing. Some values can't be changed, and they are immutable values. In Python, all things are mutable because everything's an object, unless there are specifically no ways of changing the properties of the object itself. Let's go into an example. For example, if you define these to be tuples, there are actually no ways of adding or removing an element from a tuple. If you do a.append, you're going to get an error saying that tuples don't have an append method in them. If you do a equal a plus something, you're going to create a new tuple. You're not going to be modifying that one. So tuples are immutable. Let's take a look at another example. Imagine you have two numbers, such as 8597 and 8597. These are the same value, 8597 in both cases. And you can see that the IDs are the same. So why did this differ in lists when you created two empty lists, but not in integers? Python has this optimization where when an integer is created, then it won't recreate it if another one identical to it is used. So here Python knows that 8597 has already been created, so it doesn't create a new one. Integers are also immutable. You can't change them. New Python developers often believe that if you do something like 8598, now B should change as well, because you have changed this number here. But that is not at all what's happened. This value was created first, and A is a name for that value. The name assignment happens with the equal sign. And here you have created the value 8598, and you have given it the name A. However, B is still a name for 8597. That hasn't changed at all. However, if you do print these IDs, you can see that that's all correct, and they are now different. They are identical at the start, and then they differ afterwards. As I said earlier, most things in Python are mutable, except for tuples, strings, integers, floats, and booleans. I believe that's most of the immutable ones. All the rest are mutable. And if you want to create an immutable class and immutable objects, just don't add any methods in them that can change the object's properties. For example, if you have a book object and you want it immutable, don't allow anybody to change the name property of that book. One more example for beginner Python developers is that if you create a string called hello and give it the name A, and then you make B and give it the same value as A's value, then these will be the same. If you do plus equal, that is the same thing as doing equal A plus world. So you are reassigning the name A into this new string, but B will still be hello. So this will change the name A. It won't change the string hello. So that's something important to remember. Immutable types, like strings, you can't change them. It's physically not possible in Python to change them. So whenever you are assigning, you're always going to be changing the existing name and not the value. And the same thing for tuples, integers, floats, and booleans. That's it for this video. I wanted to tell you a bit about mutability in Python. In the next one, we're going to learn why it's important to know about it. So stick with me, and I'll see you in the next video. Hi guys, and welcome back. In this video, we're going to talk about mutable default parameters. This is something that you really need to know about in Python, because if you make this mistake, it's going to cost you a lot of time trying to find out what the problem is. So let's get started. Here we've got a student class, and in the init method we have two parameters, the name, which is a string, and the grades, which is a list of integers, but it has a default value of empty list. So by the way, this is how you type hint when you have both a type hint and a default value. I'm not sure we've looked at that before, but nonetheless, that is how it goes. So you've got your grades. You can pass in a list of grades if you want when you create the object, or you can use the default, which is an empty list. Then you set that, and when you take an exam, you pass in a result, such as an integer. We're going to put that in there, actually, and then it appends to self.grades. This is bad. I've put a comment in there so you don't do this. Never make a parameter equal to a mutable value by default. Here's why. You created your student, Bob, and you used the default grades. Then you made him take an exam, which appends 90 to self.grades, and finally you print Bob's grades. So let's save that and run it, and you see you get 90 out. So yeah, no problem. But then what if you create one more student, such as Rolf, and you don't make him take any exams? What are we going to see now? Well, let me run this code, and voila. Both students have 90, even though only Bob took an exam. So this is why mutability is so important in Python and why this is a bad idea. The function parameters, these default ones, evaluate when the function is defined, not when the function is called. So when the class is created, this function is evaluated so that Python knows what the parameters are and what the name is and so on, and this one too. And there, this default value is created. That means that if you use the default, self.grades is a name for this specific list. And when you create two students, self.grades in both of them are names to the same list. This one that was created when the function was created, not when the function was called. So as long as you're using the default parameter for all your students, they will share grades. That's probably not what you want. However, do note that if you pass in your own lists here, then these will be different, because now Bob is using this list and Rolf is using this one. If you then define a third one that uses this one, those two will share grades, but this one will be unaffected because that's using his own list. So avoid this problem by not using mutable default values for parameters. Instead, what you can do is you can make it equal to none, and then you can make this equal to grades or empty list. And what happens here is that if this is none, then none or empty list will evaluate to empty list. Now, instead of list of integers, you may want to do import optional as well and make this an optional list of integers. That's just a slightly better way of handling this here. So Python knows that it is optional and it may not be a list initially, it may be none initially, but you're going to set it to a list later on. So this is a better way of handling that type hint as well. So now this will work the way we intended to. By pressing play, you see that Bob has 90 and Rolf has nothing. This is very important. My word of advice is to not use default parameter values that are mutable. Just stick to immutable ones like integers, strings, floats, booleans, tuples, things like that. And if not, use this pattern here to define them inside the function and not in the parameter list. Thank you for joining me in this video. I hope it's been useful, and I'll see you in the next one.